folks.
Scroll up so fast, followers chase shadows they cast, promises of a future so fast, building faith that's gonna last. Cult of code, we're in the show, we follow, they never slow. Cult of code, no truth to show, in the shadows we grow. Cult of code, win the show.
Just getting set up here. Laughing Panda, good to see you. How you doing? I think, am I ready? Let's see, how ready am I? I'm doing pretty well, Panda, pretty well. Thanks for asking. I'm glad you're doing all right. Fake Mario fan. Hey, Laugh, good to see you. If I go... All right, that's just me. Welcome, everyone. Welcome. We are gonna be talking about how software is a piece of crap. Just all software, just software in general. All software is pure crap. Haha, yeah. Programming gloves on the shelf, yeah. Just a second here. Just a second. I guess okay, hang on. If I move this over here. Yeah. All right. Okay. Okay. I think I am basically ready to go. Now, I could sit here and I could wait for like, a few more people to show up, but who cares? Who cares? Full screen, new setup, so many changes, except for me. I haven't changed. Your mom is still here. All of your moms are still here. There's still an adequate amount of momage happening. Full momage. It's nothing but moms. All the way down. No, mine's still dead. What you don't know is that I practice necromancy. No, not the other one. Necromancy. Okay, it is different. Which means technically alive, but in a dead form. Listen, I don't make the rules. I just play. Hate the game, not the player. Know what I'm saying? All right. All right. I think I'm ready. Stupid ads. Okay, well, just before ads show up, here's what we're doing today. I think I'm basically ready. I've got ads on the Twitch side, which I have to get through. So I've got just a few studies, actual scientific studies, and we're going to talk about how software is not in good shape, and it hasn't been for quite some time. And anybody who gives me the Shreyas argument, oh, but my developer experience though, everything is great though, can go suck on a potato. I had fun getting through that steel concrete vault. That thing was sturdy when we got it. Oh man, that was a blast, Panda. That was a blast. Hey ALS, good to see you, man. Good to see you. Okay, I'm gonna get the ads out of the way on the Twitch side. And then we're gonna get right to it. Because I don't have a lot of time to do a stream today. But it's gonna be a good one. It's gonna be a good stream. So I'm gonna switch over like this while I wait for the ads on Twitch to end. So I've got a few articles, just kind of like a light entry point that we should get through pretty quickly, because I kind of want to take the last stream that I did where I talked about how web is doing terribly, and I want to take this stream about software, and I kind of want to chop them up and turn them into like shorts and educational content and stuff like that. Just start piecing together some things and then putting it on my Enlightened Programming website. So this is by no means a like the comprehensive list of articles I have. Just while I'm waiting for this stupid Twitch ads to end. Damn it, Bezos! I have like a whole. I have spent. I can't even count how much time now. It's been weeks. Grabbing like actual studies one after another, and it is very difficult to find like solid data on software issues. And even the data that I have found on software issues, it's like you kind of have to piece a whole bunch of stuff together. It's like a puzzle. Hopefully it comes together correctly, and then I can shut all the people up who think that everything's just fine and it's never been better. I do that, and then how much time is left on the ads? Off like 45 seconds. All right. What on earth is my machine doing right now? Hang on. Oh, okay. I have to get my I have to do my where's my streamer bot? What the heck happened? This is exactly what I'm talking about. What a great way to start the stream. I'm trying to talk about software not being in good shape, and I immediately, here we go, immediately have issues. There we go. Okay, now that that's running, I hope. It's fine. Okay, now that that's running, let's get into it. So the first article that I have up on screen, it's just an article that kind of is like a little bit of a discussion on some of the problems that happen when you're writing code. And I think it kind of touches on a few things, including primarily abstractions, and why I think that is the primary reason why not just web but software sucks these days. It's pretty recent too, so I mean, I think this argument holds true no matter what, but yeah. Okay, so the article kind of starts off with like things you need to be doing. Writing code correctly is hard. Verifying code correctness is impossible. Impossible. Here are some reasons why. Generality, even if your code behaves correctly once, it will it do so for all cases, for all machines, for all times? False pass. Failing tests indicate the presence of bugs, but passing tests do not promise their absence. I actually think this is a banger argument. Just because your tests pass does not mean that you have no bugs. Lack of certainty, you could write a formal proof of your code's correctness, but now you must wonder if the proof is correct. You would need to prove the proof. This chain of verifying the verification would never end. Although I feel like that's somewhat of a solved problem in legal circumstances with chain of custody. There's something about that feels like you could reach a point where you would have enough verification. So I don't know if I buy this one 100%, but it's still a good argument. It is folly to pursue certainty of your code's correctness. A bug may be hiding in a dependency that you'll never find. This is abundantly true with like NPM packages or other languages that use package management, where you just download libraries like there's no tomorrow. Yet we should not despair. We can still decrease the risk of bugs via greater understanding and due diligence. God forbid you ask any programmer to do that. They'll run away. Abstractions. What is greater understanding? Let's focus on one facet of understanding which comes up frequently among programmers: abstractions. Abstractions are mental models of how stuff works when we treat thing A as if it were thing B. Metaphorically, the result of the data compression that occurs in your brain, seeing the forest for the trees, used all the time in day-to-day life. The word abstraction has many meanings in programming. It can also refer to layers of code that hide complexity. This post will only be talking about abstractions in the cognitive sense. So examples of abstraction. We treat our bank deposits as if the bank simply stores that money for us. Truth. In reality, the bank does not just store the money we deposit. It loans away, invests most of the money that people deposit. Our money does not sit idle in a large pile in a vault. Damn it. Scrooge McDuck lied to me. The abstraction works because banks still keep enough cash on hand to handle most withdrawals. We treat time as if it passes at the same rate for everyone. Time dilation slightly changes each person object's flow of time based on their speed and how much gravity they're under. Are we seriously getting into like the philosophical physics, quantum physics stuff here? GPS satellites orbiting the Earth have to adjust their clocks by approximately 38 microseconds per day to account for time dilation. The abstraction works because the effect of time dilation is too minuscule to notice until you're doing extremely precise engineering. All right. One way to form abstractions is by removing details, creating a simplified view of something complex. For example, most people that drive do not know much about the inner workings of their car. Their perspective of the car can be boiled down to: ignition turns on car, accelerator makes car go, brake makes car stop, wheel turns car needs gas, diesel, ooga booga, I am caveman. Knowing the above abstraction makes it unnecessary to understand the inner workings of car engines. Most drivers have only this working knowledge of cars, and they can drive where they need to go. When we use a programming language, it provides abstractions that allow us to operate computers without understanding their inner workings. Basic language features such as loops, if conditionals, functions, statements, and expressions are all abstractions which hide hardware level details like CPU instructions, registers, flags, and details specific to CPU architecture. And by the way, I've been doing side research on CPU architecture, and it is embarrassing. I'm calling myself out here. It's embarrassing how little I know about CPU architecture or even memory architecture. Like, what's the difference between storing memory in RAM versus a hard drive, or operating on memory and RAM versus a CPU, if CPU even has memory, and what is like operation caching and stuff like that. It's shocking. It's embarrassing how little I know about that. It's only been since I've started doing this research that I started realizing how little I know. And if I'm going to be asking other developers to know more, then maybe I should also know more. And I know very little. OS level details, call stack management, memory management, portability. Languages abstract away the need to concern ourselves with differences between different machines. This is also quite true. Any compiled Java program, like a jar file, should be able to run on any machine that has a Java runtime environment on it. A Python script should be able to run on any machine with a Python interpreter. A C program should be able to compile and run on any machine if the machine has a C compiler. Right. So I think this section right here stood out to me. I did like a cursory reading. And I think this is a good summary of the things that I talk about when it comes to abstractions like React, which essentially just make you more stupid. Yes, React makes you more stupid. Does the amount of registers it has internally, AMD 64 is insane. Oh yeah, laugh. Yeah. And I don't even know all of the inner workings of that laugh. I just kind of like started looking into that and realizing how little I knew. It's bonkers. By the way, hey Moldy on YouTube, man. Even compiled machine code doesn't represent what it actually does. That's correct. Yeah, laugh. That is correct. If you compile machine code, it is my understanding, which I could be wrong about, it is my understanding that it is simply instructions that hardware acts upon. But depending on the hardware you have, the act itself can vary. And so, understanding the hardware and how it would act on those machine instructions and that variability, man, we are pampered little country bumpkins over here in programming land. Seriously. You don't know that CPU. Shut up, Moldy. Okay. Yeah, Spiro Derpopoulos. That's my last name. It's Spiro Derpopoulos. Moldy, whatever. Okay. I still talk to your mom on a nightly basis. Not a lot of talking going on. Some of it is meant to be invisible, but some of it you should know about. Yeah. Yeah, I agree, laugh. I agree. There's yeah. You should know about at least some things. I think it would be quite useful I think it would be almost, would probably be like a major impact to just the general, like the industry in general, if 25% of the developers we had today understood more about like how their hardware would possibly act out machine instructions. Just like, hell, even maybe like 10%, like just a bit more than now, So, yeah. Hey Shreyas, good to see you. I got a Ouija board. What are you talking about, Moldy? YouTube is the peasants of viewers. I have no idea what YouTube chat talks about half the time. Okay, let's keep going. Abstractions fail. Unfortunately, abstractions fail. Language abstractions are not enough if you care about code performance. To speed up your code, you need to know hardware level and OS level details. Maybe not always true, but like probably true more often than not, I would say. Porting programs that have external dependencies such as Dynamic libraries or network requirements is not as simple. They cannot simply be moved to another machine and run. One does not simply move to another machine and run. Extra setup and knowledge are required. Car owners who only know the bare minimum can end up stuck in a broken down car. If the driver doesn't regularly change their car's lubricant oil, they'll shorten the engine's lifespan. The driver's abstraction works well in the short term for a single drive, but fails in the long term many years. Joel Spolsky describes such failing abstractions as leaky and put forth a law of leaky abstractions. All non-trivial abstractions to some degree are leaky, which is similar to the maxim from statistics. All models are wrong, but some are useful. When we write code, we use leaky abstractions all the time. Here are some random examples. Garbage collection takes away the burden of worrying about memory management unless we care about latency jitters. C++ smart pointers make memory safe as long as you don't store any raw pointers from it. Hash tables are fast because they have O1 operations, but arrays are faster for smaller sizes. Passing by reference is faster than passing by value, except for cases of copy elision and values which fit in CPU registers like ints. Fortunately, many leaky abstractions crash your code when they fail, so they're easy to address. However, some may just produce undefined behavior or performance degradation, which are harder to identify and fix. This is like probably it's like a silent killer, so to speak, Press X to doubt. So if abstractions can be problematic, then should we try to understand a topic without abstractions to know cars as they really are? No. When you dig beneath abstractions, you just find more abstractions. It's turtles all the way down. Underpinning our abstraction of cars, there is an understanding of each component's purpose. Beneath that, the chemistry of combustion and the mechanical engineering of the engine. Beneath that, the mathematics, physics that model the forces of our universe. These layers of abstractions go down until we hit our most basic axioms about logic and reality. As programmers, we should see our knowledge as a house of cards made of leaky abstractions and assumptions. We should have a healthy amount of skepticism of everything and everyone, including ourselves. Unless you're me, in which case I am an Omega GigaChad developer. No, not yet, Trace. The biggest ones to know are branch prediction, caching, cache lines, page sizes. I hate these. Man, imagine that. All models are wrong. Programming is making models. Yeah. Anytime you program, it's wrong. It's wrong. I don't care, Shreyas. Hey, I'm Seabass. Good to see you. I think you're a new follower from I don't know, it was a few days ago, but welcome in, man. Hope you're doing well. Trust but verify. Programmer should have a trust but verify policy. Here are some examples. Trust the information that people tell you, but verify it with what the documentation says. I will do one step further. Never trust any information anyone tells you ever. At the ripe old age of 40, I can tell you that. Test your beliefs by trying to disprove them. If Arvis is around, he better do his damn job. Test your beliefs by trying to disprove them. You wrote tests for your code change and they pass on the first try. Try running the tests without your changes and see if they still pass. They may have a bug that makes them always pass. You've refactored the code, which should be a no-op. All the tests still pass. Check to make sure there are actually any tests that run the code you refactor. You optimized your service and you see the expected reduction in resource utilization. Check to make sure your service is not just handling fewer requests at the moment. You've submitted a code change and you see no problems in the service the next day. Check to make sure a rollout occurred that day and your code was included in it. Always measure impact when optimizing code. Code changes that appear to be theoretically faster can end up being slower due to factors revealed in lower layers of abstraction. Yes. I mean, yeah. Even if you have tests for your code, whether tests pass or not, you should always be asking why they're passing or why they're not passing. So, yeah. Beware of unknown unknowns. And I mean, like, some of the other stuff here is really good too, in my opinion. The scariest epistemological issue for programmers is the unknown unknown. There are things you know you don't know, things you don't even know that you don't know, which is the story of my life. These unknown unknowns are the root of abstraction failures and the reason why programmers can never accurately predict how long a project will take. You may have never heard of sanitizing user inputs. If you use user-provided strings as part of a SQL query, your service can be hacked via SQL injections. Character encodings, like random access, incomprehensible characters if you try to read text data using Java heap size, lack of heap memory, configure a larger max heap size for Java. If you have not heard of these topics before, you may not even know that you fell into their pitfalls. Right. So it's the unknown unknowns. There is no surefire way to catch unknown unknowns when they're around, but we should check under at least one layer of abstraction to look for them, especially when a project requires learning something new. You should always learn more than you need to. Doing so will mitigate the risk of being surprised by abstraction failures. When learning, working with an unfamiliar platform, language, tool, library, technology, read more documentation than just the bare minimum you need. I totally agree with this. Watch videos, conference presentations have the highest quality in my experience. Read blog posts, read the source code. This is a solid one. Grow your understanding of abstractions you have to work with. Learn about features recently added into your language. Read through all of the public functions of libraries, not just the ones you're using. Skim through all of the flags of a CLI tool's man page. Learn at least one layer of abstraction lower than you need. Learn about your compiler's optimizations. If you're running a service, learn about your orchestration platform. If you're working in Java, learn about JVM. If you're working in Python, learn about the Python interpreter. If you're working in JavaScript, just go touch grass. Conclusion: abstractions are necessary as they allow us to think efficiently, but they are treacherous as they can make it appear that we know enough. Programmers who learn superficially will not succeed on difficult projects that come without known solutions and involve multiple domains of expertise. That said, the ideal put forth by this blog post needs to be balanced against reality. Obviously, we can't take time to learn every little thing when we're in a rush. Also, beginners can't be expected to be so thorough. Ideals should be balanced against real-world considerations. And real-world considerations should be balanced against ideals. We should be willing to pay some short-term costs for thorough learning and verifications, not just for writing correct code, but as part of our long-term journey of becoming capable and principled engineers. So generally, I agree. I agree with the overall sentiment here is that if you even took just a portion of what this post talks about and you applied it, a bit more even-handedly across more developers in the industry, I think there would be a pretty big positive impact on software in general. These abstractions, like this abstraction talk, is not just true in web, but like on this stream, I'm focused more on the software side. So I just thought that this was a good start to the topic. So I've got a few other things to get into. Let me catch up on chat. I saw your back-end banter chat. Sorry about the job situation. Yeah, that sucks, IMC Bass. I know, but I'm doing all right. I appreciate it. And yeah, that back-end banter thing was it was a good convo. I enjoyed it. That known unknown is a great comeback to the inheritance is okay if you plan correctly fallacy. Right. The unknown unknown. Inheritance is okay. Right. Inheritance is okay if you plan correctly, except for the things you don't know. And that's where the inheritance thing starts to become like, yeah. Okay. So there's a reason why I'm kind of jumping to this. There's kind of like a few things that kind of lead up to the meat of the argument here. And I'm going to talk about some symptoms. So I think this kind of like lightly touches on a symptom of where the state of software and web is today. This is another symptom. This is for 2023, but 2024 is worse. So if you look at some of the statistics of like the cybersecurity issues and what they're driven by, there's like we have a huge problem. So let's see if I can zoom in without like sure, like that. So for example, just the starting point here, if it were measured as a country, then cybercrime, which is predicted to inflict damages totaling 8 trillion USD globally in 2023, according to Cybersecurity Ventures, would be the world's third largest economy after the US and China, surpassing the wealth of entire nations. So like the entire, yeah, there you go, laugh. The entire cybersecurity, cybercrime industry is huge. It's a big problem. And so let's just get into it just a little bit, right? Cybersecurity Ventures expects global cybercrime costs to grow by 15% per year over the next 3 years, reaching 8 trillion USD globally this year, 10.5 trillion USD annually by 2025, up from 3 trillion USD in 2015. That is not a small amount of money. Cybercrime, cybersecurity are new entrants into the top 10 rankings of the most severe global risks over the next decade, according to the World Economic Forum. Conspiracies aside, you shall eat bugs and you shall enjoy it. Now taking the 8th spot, cybercrime now stands side by side with threats including climate change and involuntary migration. Sure, I mean, sure. Again, depending on your conspiracy bent, In 2018, the U.S. Department of Justice stated that less than 1 in 7 cybercrimes were reported. In some countries, the reported rate was even lower. Cybersecurity Ventures believes that reporting practices concerning illegal cyber activity are improving, but in 2023, we're still faced with a situation where less than 25% of cybercrimes committed globally are reported to law enforcement. So, just this last point here. According to IBM, the average cost of a data breach, including lost business detection and escalation notification and post-breach response, was 4.35 million USD in 2022, representing a 2.6% increase from 2021. This figure was reached by averaging out the activity-based costing related to 550 organizations suffering data breaches across 17 countries and 17 industries such as healthcare, finance, and energy. I mean, even if it's not actually, even if it's not actually in trillions, let's just say it was in the millions or maybe even billions. Just general, right? If you just took all these numbers and you kind of just said, well, maybe some of them are underreported, maybe some of them are overreported, that's still a lot of damn money annually. And that's still a lot of issues. That's only the financial cost of these issues, not to mention some of the other costs that come with these problems. And that's only, according to this, cybercrime. You have ransomware, which also costs a bunch of money. You have crypto crime, which also costs a bunch of money. And then you have major hacks, which things that bring down entire services, or even just issues with like CrowdStrike or similar issues that have come up, where it's just like a general mistake that, how do you put a number on the kind of cost of these kinds of software issues? So, the entire, when you take everything, when you take all of these numbers and you put them together, I would be shocked if we're not spending billions of dollars a year overall on all of these issues put together. And that's just, monetary value. And so my entire point for bringing this up is that as we see costs for these issues go up, and we see, for example, I think we just passed it. The job market for cybersecurity is actually increasing. I don't know if it's increasing by the numbers given here, But it is definitely like one of the bigger ones. I think there was a, maybe it was a Stack Overflow. I can't remember. There was a study or like some kind of metrics that were done kind of like with the industry as a whole. And like cybersecurity jobs are kind of increasing. Like they're on the way up. There's more demand for them. Why is that? Why do we have more of that? And I think in part, not as a whole, but in part at least, it's because we don't write software the way we used to. We rely on a lot of crap and build crap on top of that. And all it does is it creates more opportunities for exploits. Now, it's great for me to say that. Where's the proof, right? And I think I'm going to start getting into it. But you can see like this article goes on and on and on. The FBI information is pretty good information about like how many how much cybercrime and cyber fraud happens, in the States, and potential costs of all these things. That's a pretty reasonable number, somewhat more realistic. And that's not just for businesses. We've got to consider like how it affects individuals, right? So, okay. Yeah, that's fine. So I'm going to close this one. We're going to get over to here. Now, let's assume for a moment that we could all agree that software is not in a good state. What would that mean? What would that mean? So I'm just going to briefly go over this, and then we're going to get into some meat. Let me check on chat here. There's a tendency to digitize, virtualize more aspects of life, and companies rush into it, which would invariably lead to shoddy work. Yeah. Yeah, laugh. Yeah. Kitchen appliance firmware. What? Yeah, I know. Laugh. I agree, man. Like, what is that? It's in a mid state. It's in a... I would say that's charitable. I think at best it's in a mid state. Okay, so Synopsys recently co-sponsored the cost of poor software quality in the US with the Consortium for Information and Software Quality. The report investigates the ever-increasing financial impact of poor software quality and the factors that further its continued growth. At a high level, the report's findings reflect that as of 2022, the cost of poor software quality in the US, which includes cyber attacks due to existing vulnerabilities, complex issues involving the software supply chain, and the growing impact of rapidly accumulating technical debt, will total approximately $2.41 trillion. Let's assume that they're like 50% wrong. Even if it's 1 trillion, even if it's $1 billion, that's still a lot of money because of software issues. The report examines these challenges in depth and provides guidance and suggestions for how organizations can best address them, which we will summarize below. What contributes to the cost of poor software quality? Cybercrime. So yes, we know that cybercrime is increasing. Cybercrime losses due to software vulnerabilities rose 64% between 2020 and 2021. That's bonkers. It's another increase of 42% from 2021 to 2022. That's insane. Technical debt. Technical debt has become the largest obstacle for organizations wanting to make changes to their existing code bases. Technical debt refers to the cost of rework and software development, accumulated deficiencies that desperately need attention but are very expensive and time-consuming to mend. But addressing these issues is critical to preventing problems that could leave data and systems vulnerable, which is exactly why I'm following this chain of articles. SysQ found that these issues are not being resolved, and technical debt in the U.S. has risen to roughly $1.52 trillion in 2022. That wouldn't surprise me. I wonder if that's even undersold. Software supply chain problems. Most important to this report's finding this year is the impact of software supply chain challenges. SysQ reports that supply chain problems with underlying third-party components are rising significantly. Problems stemming from weakness in open source components within the supply chain increased an alarming 650% from 2020 to 2021, a trend supported by the annual Synopsys Open Source Security and Risk Analysis Report. The data in the Synopsys report continues to underscore the importance of responsible and comprehensive open source security and risk management. With high-profile incidents like Log4Shell and SolarWinds, I remember those, these types of issues are becoming a constant in the software development world. And it hasn't stopped this year, has it? Perhaps no cybersecurity trend was bigger in 2021, 2022 than the scourge of supply chain ransomware attacks. Among the biggest attacks was the Colonial Pipeline ransomware attack, which affected the east coast of the US in May 2021. There were also ongoing issues related to supply chain security due to a breach at a software management vendor, SolarWinds. Yeah. So then they talk about the inability to be able to patch these things, sometimes because you can't tell where the problem lies when you have a bunch of open source things that you've pulled in. So when it comes time to like actually track where the problem is, hey Justin on YouTube, thank you, man. You don't know where to look. So think about like NPM dependencies and whatnot. And then some things you can do, and then the report. So I thought this was like, this kind of is a good next step. And then I was thinking about like, well, we actually have some data, don't we? We actually legitimately have, hey, Guana Katuteller, I totally butchered that. Thanks for the follow on Twitch just now. Say hi if you're here. But if you're doing a flyby follow, thank you anyway. It also includes what you could sum up as package managers. It maybe just do like the whole thing. Just include any package manager as any package manager. Let me just see if I can get this. Yeah, okay. So here, we'll do that. Let's go like year, newest to oldest, oldest to newest. Okay. So I just want us to look at the number of, like, the CVE reports are, if you don't know what they are essentially just vulnerability reports on, I believe it's mostly centered around like anything that has some kind of vulnerability, whether it's software or web. I believe you can submit CVE reports for websites. I could be wrong about that. But essentially it's a pretty standard place to go read up on like open vulnerabilities that you might need to patch on something you're working on. But if you look at like just the total numbers, even if we just take the totals, right, per year, look at the jumps. Even let's just take like say 2021 to 2023. It's not going down, is it? It's increasing by almost, what would this be, like maybe it's adding like a third you know, in 3 years ish. If you go back further, I mean 2017 had half as many vulnerabilities as 2023 does, like 50%, a 50% increase you know, over the course of like 6 years. So it's huge. Just overall it's huge. And if you go back to here, we'll do a comparison. I think this is a very telling thing. Okay. 6 string, 100%, not, yeah, okay, 100% increase. You're right. I said 50%. Playing advocate, how much of it is due to just more software existing? Yeah, okay, so Laugh, I think this is kind of, I'm kind of want to make the hint here, because look at this. Look, something happened. I don't have the data to prove this yet, but I think something happened here where particular languages and frameworks became more abundant in 2016, 2017. Okay. And if you remember our last stream, I actually pulled up data. You can go back on the last stream, and we were looking at things like package, or like JavaScript payload size, and there was something else that we were looking at, and it had a marked increase in 2016, 2017. And in some cases, in some of the like those web statistics we were looking at, it was like just like a straight upshot around the same year. So I have a feeling that somewhere in this year period, something happened to languages, frameworks, etc., made a significant increase, and we kind of missed it. It kind of just kind of like skated by. And what you can also do is you can look at comparatively previous years. So check this out, right? So I'm trying to make the case here, so just bear with me. So you got 14,000 in 2017, which is a huge jump from 2016. And then from 2017 all the way to current, it has done nothing but increase, usually by quite a lot. Whereas if you go back to previous years, something before 2016, there was something different, and you can make the case that we didn't produce as much software back then, but I don't think we produced that much less software. So look at this. 2007, let's just go back by 10 years. 2007, 7,000 approximately, and then we went down, and then we stayed about the same, and then we went down, and then we went down, and then we went up a little bit, and then we went down just a little bit, and then all of a sudden we start going up. But even then we went down again, and then we stayed about the same, right? So like it's a huge difference. Oh, even just going back like 10 years, but even if you go back further to say like the early 2000s, we had tons of software still. Maybe not as much as we do say in the last few years, but still quite a bit. And the number of vulnerabilities that we had then is still nowhere near the same as current years, and it is not following the same trend as current years. And I think that you could make the argument that this is at least in part, not completely, but in part, because of the way that we're using that we're relying on current nice abstractions and developer experience and things like this in the last few years. It's making things worse, not better. And I think the data bears this out. I wonder what an evaluation of the types of CVEs in those 2 years would reveal. That's a good question. Laugh, I'm going to do that. I'm going to make a note of that here. That's a very good question. So I'll go CVE. Compare types of CVE. It's like a breakdown. Yeah, that'd be NPM ecosystem. I think that's part of it, but I'm also including software in here because I think software issues are included in this data. And if you couple this data in terms of vulnerabilities reported, along with the increasing number of expenditures in cybersecurity, things like this, there is a case to be made that software is also a big factor in this, and it's not just web. What tech came out, OS frameworks, etc., and what the tech trends were. Well, I can tell you that like 2016, 2017 was, I think, a big year for React, which is one of the reasons why I pick on React so much, because I genuinely do think it was like it like attacked healthy tissues in the body of the tech industry and started degrading the industry. And it kind of infiltrated into other things. Other things kind of took note of it and decided that's got to be the way we do everything else, including software. But there's probably other stuff, you're right, Laugh, that like came out. And I think it probably is worthy of me looking into that. So what came out in 2016, 2017? I'm going to make a note of that too. Yeah, that's good. Okay, so then I actually have some studies. So this is going to be very, it's going to be very in your head. This gets very nitty gritty, but this is the kind of data that I think is missing from this entire debate. The every time I debate this, it always comes down to my feelings, though, my developer experience, though. How about this intuition about the way you do software, though? There's no data. So I'm starting to get into data. This will be based on software, and further streams will continue this data-driven look with actual like scientific studies. I'm going to put them up on my Enlightened Programming website, but I'm going to put them behind a nominal paywall because this stuff is taking a lot of time. And frankly, I do not see anybody else looking at the data this way. I do not see anybody looking at this. And I feel like I'm the only person who's actually willing to do a deep dive and actually string together an argument based on data about why we are in a very shitty place and we need to do better. And so I just feel like it's worth something. You know, the time and effort is worth something. So I don't know, I might charge like $1 or $2 or something, you know, just to get something for the time. But I'm doing all this for free on my stream so that people can get it for free. And then I'll probably just leave it up on Twitch maybe, and you can always go back. But yeah, so all this to say, I'm going to apologize in advance because this is not like watching, Prime or Tej or somebody code and do like, I don't know, something fun and glorious. This is very data, like tedious. It's going to be boring, but no one else is doing this. And I'm sick and tired of having these feelings-based intuitive arguments. I want to at least take a stab at it. This is a very interesting trend I haven't seen highlighted elsewhere. Same. I don't see anybody else looking at things like to this level. I think you've hit something here, Spiro. Good game. Thanks, Laugh. Yeah, I hope so. Hey, Marco on X. Back in 2014, React made sense. You'd be wrong with your take. No, I'm not wrong with my take. I completely disagree with you. React never made any sense. React was a stupid choice. You never actually needed it. It was just a skill issue. People just complained that they couldn't template the way they wanted to. It was all based on developer experience. I've already gone into the history of why React was made, how many times it was refactored, and for what reasons. And I'm going to present that data, and you're never going to convince me that it was anything more than catering to the lowest common denominator of developer skills. We should have just asked developers to just do better, not create stupid, abstracted, hide away what's going on solutions, thinking that was going to be the answer. It was not the answer. It never was, and it never will be. And anybody who does anything like React in the future, I will say the same thing. I'm no longer convinced by simply stating it was the right thing that made sense, and you'd be wrong with your take. I'm presenting evidence. You're not. Hey, Ray on YouTube. It was the right thing that made sense. No, it didn't make sense at all. No. And I will present the evidence as I'm doing right now. Again, nobody's coming to me and saying, here's the evidence that demonstrates that A, we needed it, there was no other way around it, and that it's done nothing but good things. Everybody always says, yeah, but it's the right thing. Why? Why was it the right thing? Do you have the data to prove it? No. What you have is some kind of subjective experience that makes it okay for you and for others. That's right, because you said so. Well, I'm not just going to say so, I'm going to prove so. And I'm thoroughly convinced after all my research that React was probably one of the shittiest things we could have done to the web industry ever. And I hope we never do it again. Coming back to software. So I have this study. I have a few studies. This one is from 2017, I want to say. What year? Doesn't say the year, does it? I'm sure I could find it. Anyway, I don't think it's that old. So, an empirical study of design degradation, how software projects get worse over time. Context. Software decay is a key concern for large, long-lived software projects. Systems degrade over time as design and implementation compromises and exceptions pile up. Goal, quantify it. Method, we constructed an empirical study on the presence and evolution of code smells used as an indicator of design degradation in 220 open source projects. Now, I can already tell you that there are some issues with just looking at this by itself and using it to make a deterministic statement that software is in decline. However, this is just one of several factors that kind of piece together the whole argument. The best approach to maintain the quality of a project is to spend time reducing both software defects, which is bugs, and design issues, which is refactoring. We found that design issues are frequently ignored in favor of fixing defects. We also found that design issues have a higher chance of being fixed in the early stages of a project, and that efforts to correct these stall as projects mature and the code base grows, leading to a buildup of problems. So essentially, the end result here that they've discovered is most things that tend to get fixed fall into the defects category, not the design issue refactoring category. From studying a large set of open source projects, our research suggests that while core contributors tend to fix design issues more often than non-core contributors, there is no difference once the relative quantity of commits is accounted for. We also show that design issues tend to build up over time. And I think this is the real killer here, is that it goes back to what we were talking about before, which is the silent killer, where you have bugs or issues that go unnoticed until time. It's a time-based issue. And you don't know what those are because you're not focused on those things. Software systems require constant modifications in the form of bug fixes and the addition of new features to satisfy end user needs. Failure to do so might lead to losing users or unsatisfied users. The pressure to keep growing and evolving the software makes it impossible to refactor and redesign when a requirement changes. This, I think, was a good. I'm not going to read everything in here, but this was good because I think this is actually representative of what happens in the real world. I think we've all been there, where in the real world you work at a company, and by the time that you get to a point where you realize that a design, not necessarily a bug, a design issue is causing you a huge pain, the cost to change that design it's too late. You're not going to be able to get the company as a whole to be convinced to spend the time to fix it, right? This eventually leads to decay in the software design and the growth of technical debt. One outcome of such decay is that code becomes more difficult to extend or understand, and as a result, the ability to evolve an application tends to decrease over time. I mean, like, in general, regardless of like some of the specificities in this study, I think this is very true. Like, this is what happens just generally. How many of us have not seen this happen in our like day-to-day what would you call it, employment? Right? Like I think about all the companies you've worked at, whether you're a junior developer watching right now or you've been around the block for like 50 years. How many times has this paragraph happened in a company where you rush towards something and you kind of ignore some of like the things that you kind of know you shouldn't be ignoring, and then by the time you always think, oh, we'll have time to fix it later, and then when it rears its head, it's too late. Right? It's too late. And good luck getting the company to be like, all right, well, I guess we're just going to have to buckle down and we're going to have to fix it. And it's going to take a huge refactor, but here we go. And then it's too late. Right? Or here's another thing. I'm kind of, what would you say? I'm kind of, spoiling a little bit of a spoiler alert. Companies that have the ability to refactor and actually don't solve anything. They actually make things worse. The refactoring makes things worse. And I have some studies that actually they don't I'm not going to say they prove it, but they're pretty damning, evidence that it's not as great as you think it is, even if you have the ability to refactor. Oh, and I see you, man. I'm not watching chat 100%. But I see you. Thank you for gifting that sub over to Laugh. Laugh, I guess you're my child. Or I guess you're a child of Owen. That's what I mean. You're a child of Owen. And he's paying his child support. Thank you, Owen. I appreciate it, man. You're awesome. You did not have to do that, man. You don't pay support, you're adopted, yeah. Omni says, problem when things work out, nobody writes about it. So, Omni, I think think that's fair, but I'm betting that once all this data and some of the data that we've seen already gets all put together, the data shows that constantly increasing problems in general means that things are not getting better, even if they do work out. So even if you have some undeterminate amount of projects that work out just fine, there's an entire general state that's showing itself on a trend of not working out. And you can even externalize. I haven't shown the data for this. It's gonna come in a few streams, I guess, at this point. But there is data that is kind of like metadata. So it would be something like overall data to show the number of defects on websites and apps and software as a whole when compared against consumer satisfaction. And you can actually see it was the same thing as we saw with like the CVE report. Something happened where those numbers just took like a huge nosedive. And it was not a small amount where you could kind of offset with like, okay, but maybe there's like unreported good stuff. And, there's just a little bit of variability in the negative stuff. And that goes the most reported. And yeah, sure. But there's just something about the last 5 to 10 years. Things just went like really, really bad. So I do think you're right. I do think that the stuff that works out doesn't get reported anywhere near as much. But I'm not sure that entirely negates the argument. But we'll see. We'll see as I go through it. Okay, so we kind of get the point here. In this paper, we represent the results of an empirical study on the presence and evolution of code smells used as an indicator of design degradation. To the best of our knowledge, in contrast to previous studies, ours is the largest study so far in terms of both the size of programs involved, so 534 to 100,000 lines, and the number of projects analyzed, 220 open source projects. This allows for stronger and more widely applicable conclusions about the evolution of design degradation and code smells. So the goal of the study is to shed light on how design degradation happens as a project ages and how traditional quality assurance activities contribute or fail to contribute towards improving design quality. More specifically, we try to answer the following research question: how code smells evolve over time? Is refactoring aimed at addressing technical debt dominated by specific subgroups of developers? Does the testedness of a project and the quality of tests show a correlation with design quality? Is there a match between the smells discussed in literature and in tools and the smells projects most commonly struggle with? So then they talk about, free and open source and etc. They talk about related work, such as previous studies and statistics that have been done, where code smell comes from, introduced by Fowler. Code smells are symptoms of problems in source code and indicators of where refactoring is needed. So the distinction is that code smells are defined at a higher level of abstraction and have a negative impact on a larger part of the software value than a localized piece of code. Code smells have been associated with bugs and code maintainability problems. Now, I feel like code smells is a bit just a bit too abstracted, but I think what they've done in this study is good enough in that they've kind of determined where like a clear delineation when there's like a code smell equals a design issue versus a bug. And if you can clearly identify that there's a code issue or a bug, I don't feel like it falls under code smell territory anymore. I think you've pretty definitively nailed down what the problem is. And that's why I think this study is like a good one, because think what you will of code smells in an abstracted sense, but what they essentially did was they said, well, there's kind of two things going on here. There's bugs and then there's and then there's design issues. And so they kind of like looked at both of those. The methodology. So they're talking about like how they chose the projects that they picked. And so then they just, they did whatever they had to, and in order to determine like the project size and things like that, and how many contributors were there, and all of these things, right? So they looked at even things like number of commits, because number of commits help in terms of looking at overall size of the project and what are the commits for, and things like this, right? So they essentially just break down what they've done. So so they provide some averages over all the projects that they've looked at. We chose Infusion to identify code smells because it has been found to identify the broadest set of smells. Researchers have found that the metric-based approach identified by Marinescu has the highest recall and precision for finding most code smells. Infusion uses the same principle and set of threshold for identifying code smell, which was another reason for using Infusion. So again, think what you will of code smells. I'm not really, it's code smells, but again, they did break it down into more distinct categories, which I think helps the study more than not. Okay, so damn it, more ads. Okay, I'm gonna pause here. I'm gonna wait for the Twitch ads. I'm gonna catch up on chat. Let's get the Twitch ads out of the way. Hey Tack, good to see you, man. I look 40. I know I look 40. Yeah, Martin Fowler Refactoring Works. Hey Hawks, how you doing? Hawks, it's been a while, man. I hope you're doing well. Omni, I'm noticing your Omni, thank you, man. I noticed you're putting links. It took me a second to notice, but I think you're putting up links of the papers that I have. I appreciate that. So that way, if anybody wants to read what I'm reading, they got it there. Thank you, Omni. I guess I should do the same, huh? I should be on the next stream. I'll have things better organized, and I'll put up the links. Don't worry, bro. If I get this job, you'll be like Owen, be my sugar daddy. Yeah, Owen. Yeah, you're already mine. Yeah. Yeah. Okay, I'll wait for these ads to be to finish. Oh man, if I could, I would turn off Twitch ads. But Bezos, he needs to pay for all the girlfriends, right? The difference is I have the moms. This is how the relationship with Bezos works between him and I. I have the moms and he has the girlfriends. Ads are almost done. Minute and 20 seconds. By the way, thanks for joining, everyone. Thanks for joining, everyone. Needs to pay his $434 trillion cybercrime losses. That's right, Laugh. Yeah. Have scoliosis. Yeah. Yeah, man. 50 some odd seconds on the ads, and then we'll keep going. I hope everyone's doing well. If there are people watching who I haven't said hi to, hello. You guys are awesome. There's probably some people who haven't said anything or just watching, but thank you all for watching, man. Can't even find the Infusion code scanner anymore. Yeah. I know. Listen, from Bendy and your mom for tears. Shut up, Tag. I don't think it exists either. I think this is 20. I think someone posted the timeline. It's only a few years ago. But I think the data still holds true. No joke. If you need some info, I will happily donate when I'm working. I appreciate that, Owen. I appreciate that. I wouldn't do that unless there was something in it for you. So, don't worry about anything. First, just focus on getting the job. If you get the job, I'll keep it in mind. Maybe we'll talk. We'll talk about something. That'd be dope. Work on something together. Okay, I think Twitch ads are done. So I'm gonna keep going here. So it is good to kind of see the distribution of the types of projects that they looked at for this study. Distribution of projects by domain. Excuse me. So a vast majority is just development. I was a little surprised to see the high number on sysadmin. I didn't think it would be this high. Over 220 open source projects, but yeah, like I get it. Communications, business and enterprise, home and education, etc., etc. And then list of smells identified by Enfusion. Now you can see that there's quite a few. I still don't think I even know what schizophrenic class is. Like, what is schizophrenic class? I don't think I looked this up. I had to look up a few of these, but I don't recall what schizophrenic class is. That's hilarious. But things like cyclic dependencies, I'm pretty sure it's not hard to tell what that is. The brain method, I had to look that one up. I can't remember what this one is, but I know looking it up. Data class, feature envy, God class, intensive coupling, missing template method, refused parent bequest, sibling duplication, shotgun surgery. Some of these sound dope, man. SAP breakers, internal duplication, external duplication, blob class, blob op, data clumps, message chains, distorted hierarchy, schizo class, tradition breaker, unstable dependencies. So like I think they did a reasonable job of breaking down like what are these smells, and I believe that at least a few of these are pretty clear smells of like their design pattern issues, like very clearly design pattern issues, and or they are bugs, right? So yeah, it was good enough that I felt like this was a pretty decent study to bring up. And then they have some math on like how they determine recall versus precision. We selected data from the Git repositories of the 220 projects. From the project start date until April 25th, 2013, we collected a total of 33,070 commits across the 220 projects. From the initial code commit, we calculated the code smells added or removed by each subsequent code commit to a project. For each commit, we also calculated the number of modified lines. We categorized the code smells into broad categories, which we just went over. We collected the number of test cases present for each project after each code commit, an indicator of the testedness of the code. We also calculated the code coverage of the test suites. Coverage metrics such as statement coverage, branch coverage, path coverage, etc. are the indicators of quality of the test case. We gathered different coverage metrics such as statement coverage from Emma, branch coverage from Cobertura, path coverage from JMockit, and mutation kills from PIT. We checked whether there is any difference between the low, less than 30%, and high, more than 60% tested, measured using the coverage criteria of projects and total number of code smells. The results. So I think this is where like the meat of the meat is. 6-string, how strongly do I follow clean code? This is my opinion on clean code. I think clean code is code that is maximally performant and maximally bug-free. And that's it. That's it. And if you're able to achieve those two factors, in my opinion, the code that you generate to achieve those two factors is probably also at least decent, if not good quality code. And you could consider that maybe that falls under clean code. But I think clean code is not actually code that is clean. It's actually the output of code that is clean. And that is max performance, max bug freeness, if that makes sense. That's what I would consider clean code. It's a little bit of a different view on it. So, how code smells evolve over time? To answer our first research question, we collected the total number of code smells after each commit. We normalized the smell count using feature scaling, which gives us a score between 0 and 1. So the rescaled value would be x minus min x over max x minus min x. Previous studies have shown that normalizing the smell count using the project size reduces the bias of larger projects on the overall smell count. For our study, this wasn't necessary. Our aim was to identify general trends across projects, not to look at differences between them. There was therefore no need to normalize based on project size. We looked at the code smells change trend for each project. For this purpose, we calculated the effect size of week on normalized smell count using a linear regression model, giving us how much smell count changed for each project per week. Then we categorized each project into one of three: increasing, decreasing, or unchanged. If the effect was positive and larger than 0.005, we marked those as increasing. We selected 0.005 as our threshold because this indicates a change of less than or equal to a 0.5% of the number of smells, or at most one smell added or removed per week. For negative effect, we applied the same threshold and marked the project as decreasing. Any other project was marked as unchanged. So in this table 5, we report the percentage of each of these categories. We also checked whether the effect size of mean smell count change of increasing and decreasing groups are different. So that would be your T, DF, and P value. I think I see what they're getting at here, meaning that there's a strong evidence that these groups differ in their mean effect size. So the percentage that we're increasing, 55%. The percentage that we're increasing, 7.85%. And the percentage that we're unchanged, 35%. Now, if you look at unchanged, by the way, FishPace3D on the Twitch side, thank you for the follow. Do say hi if you're here, but if you're doing a flyby follow, thank you. I think this is actually quite damning. You have over 50% of the projects that have an increasing code smell. And even if you were to take only the increasing percentage number and you put it in, like, you halved it, 50% of that 50% is just code smell that in a bucket that doesn't really mean anything, because like code smell's a bit like sketchy of a term. But let's say that it was like 50% of 50% were increasing. That's still quite a good number of all of these projects that increased in code smell that could probably be definitively put into bugs and or design issues. That's still a lot. And if you look at unchanged and you did half of that, now you're getting back up to like 30 to 40%. Even if you're being a bit more conservative than these numbers, there's still a huge number of projects that still would probably quite nicely fit under the design issue or the number of bugs, unchanged or increasing. That's insane. In my opinion, it should not be this way. To have an understanding of the bigger picture, we looked at the average number of smells across all projects and found that it grows monotonically throughout 200 weeks. Figure 2 shows the average project smelliness compared to the smelliest project in the sample. Where is Figure 2? Figure 2, week-wise average project smelliness compared to the smelliest project. Like, that's a jump. We wanted to check whether this same trend holds true for all smell categories. We found that all smells in the bloaters category, consisting of blob class, which indicates classes that are very large and complex, blob operation, which is a very large and complex operation, and data clumps, representing groups of data that appear together over and over again as parameters that are passed to operations throughout the system, increase over time. We found that code smells in the dispensables category have a mixed tendency. Data classes code smell, which are data holders without complex functionality, but usually heavily relied upon by other classes in the system, increase over time. Internal and external duplication, which identifies duplication between portions of the same class or module, and duplication between unrelated capsules of the system, respectively, tend to increase slowly or even dip over time. So that I found that to be an interesting distinction. We found that code smells in the OO abusers category follow a mixed pattern also. These include SA breakers, which looks for a mismatch between the subsystem's stability and its level of abstractness and the God class, indicating high complexity classes with a low inner class cohesion and extensive access to the data of foreign classes. These two classes showed a generally growing pattern. And I would argue that some of these things that fall into they increase over time, they don't stay stable or decrease, are some of the ones where other people who will look at like the implementations of them and go, oh man, this is like the best developer experience I've ever had. And so you can here we can jump ahead to some of the figures because they have some really good figures here. Week-wise average project smelliness compared to the smelliest project of bloater category. Like figure 4, week-wise average project smelliness compared to the smelliest project of dispensables category. The other OO abuser smells, the schizo class, a code smell that captures the scenario where a class has two or more key abstractions. The refused parent bequest code smell, a sign of inheritance relation problems between parent and subclass. Oh, but my developer experience though. And the distorted hierarchy, indicative of the inheritance hierarchy being too deep. Just like the internal and external duplication in dispensables category, sibling duplication, indicative of duplication between siblings in an inheritance hierarchy, display different growth pattern, with most of them plateauing relatively quickly. The encapsulator category had too little data to be given any meaningful insights. So does this go against my argument then? Are we proving that object-oriented inheritance is the best? Is this what this proves? Tell me it ain't so. Tell me it ain't so. Because, look, if I understand this correctly, okay, I got to make sure I'm reading this data correctly, right? Because I could be reading this data wrong. My understanding is that the number of smell counts increases on these other like these ones up here. So this would be blob operation, blob class, data clumps, data classes, internal and external dupes, right? And so you're looking at this, and these are the ones that like they go up. The number of smell counts comparative to the highest one, it goes up, right? But then you're looking at the OO ones with inheritance and stuff, and they plateau. So I don't know. I don't know anymore. Is object-oriented the way to go? Here's a similar paper. Okay, I'll keep that one open. Thanks, Omni. I'll keep that one in my back pocket. Hey, Car on YouTube. Why can I not? What am I doing wrong here? Oh, I see. Okay. So just there we go. Okay. Thanks, Omni. Are all the code bases OOP though? No, I don't think they are all OOP. I don't think so. It doesn't actually say. I guess you could make the assumption that most would be. All the graphs are for OOP projects, it seems. They were all written in Java. Were they all written in Java? Yeah, I guess they were all written in Java. So they would have, yeah, so that would have meant OOP then. I think just by nature of using Java, you could assume that a vast majority, if not all of them, would be OOP. SAP breakers, they explained it. SAP breakers. Wait, they had it. Oh yeah, here we go. It's include us. Okay, it looks for a mismatch between the subsystem's stability and its level of abstractness and the God class, indicating high complexity classes with a low inner class cohesion and extensive access to the data of foreign classes. And you can see also, I think Omni is 100% correct. If you look at Emma, Cobertubra, and Jay Mockett and PIT, I think this is all Java-based stuff. So yeah, that and God class do skyrocket. You're right, Laugh. Yeah. Yeah. They're abandoning OOP. Yes. That's right. And maybe drop it in Discord. Otherwise I'll lose sight of it here. Unless you can also drop it here, but I just might not answer, but maybe somebody else will answer. If you drop it in Discord too and nobody answers you here, then I'll answer you on Discord when I'm done. So look, we also found that the other category, all smells, like cyclic dependencies, feature envy, shotgun surgery, tradition breaker, and unstable dependencies, have a tendency to increase over time, and intensive coupling shows an oscillating behavior. Yeah. Yeah. So then you can look at the breakdown of commits, introducing trendline on top and removing smells. God class is basically just sticking everything in a namespace. Right. That's right. So they're abandoning OOP. That's right. To gain a better understanding of how design issues evolve over time, we classified code commits into one of three categories: those that introduced at least one smell, those that removed at least one smell, and those that did not impact smells. We then calculated the percentage of commits that fell into each of these three categories over the life of the projects. Figure 7 shows that as projects progress, the rate of smell introducing commits increases, the trend line on top. Smell reducing commits do increase over time, but not nearly as fast as the smell introducing commits, the trend line at the bottom. So you can see up here, commits that introduce, commits that introduce code smells is a marked difference between code commits that reduce code smells. The grouping of dots around the 50% and 100% markers are formed from the many projects that in any given week only see a small number of commits. The shaded band is the 95% confidence interval, indicating that there is 95% confidence that the true regression lies within the shaded region. So if you think of the gray area here over the introducing code smells, the red line, as the variability of errors, right? And you can see this in things like climate studies, for example. They do this too, where it's like, over given current trends, what's our ability to project correctness of our projections over the course of however many years, and they add these these gray error bars, right? So that it's like, it could be as high as this or it could be as low as this. And in some cases, that like those kinds of things indicate like, whoa, hey, your error bar is like, comparative to the positive things or comparative to the negative things, it's too big. You can't make a very good case based on the data you have. But this one in particular, even at the lowest, even if you just go with like the lowest possible value that they could get, given all the possibility of errors, right, it still exceeds the number of smells that are removed, even at its highest point, right? So there's such a difference in between these, the highest of the best and the lowest of the worst, that there's still an increase in the number of issues being introduced in each commit overall. So that's kind of like it's not good. Who takes care of smelly code? Origin of commits, introducing or reducing code smells. So here we have core contributors who introduce, and then non-core contributors who introduce. Okay, so core contributors who introduce smelly code is approximately twice the number of non-core contributors who introduce smelly code, which is a huge difference. The core contributors who reduce smelly code versus the core contributors who, or the non-core contributors who reduce smelly code is also a huge difference. And I would have rather seen the introduction one reversed. I would rather see non-core contributors introduce smelly code, but instead we see core contributors introducing more smelly code than non-core contributors. We found that less than 5% of commits removed smells and that only 10% of the developers were responsible for those commits. Because we know that a typically small core development team is responsible for more than 80% of contributions in any open source project, we next needed to see if this group was also responsible for either the insertion or removal of code smells. For the purposes of our paper, we defined the core contributors for each project as the top contributors who made 80% of the contributions in the project. As expected, core contributors, being responsible for the bulk of contributions, both introduce more smells and remove more smells than non-core contributors. We do, however, see that core contributors appear to remove more smells than they introduce, whereas the inverse is true for non-core contributors. However, we found that there is no statistically significant difference in terms of smell reducing commits and introducing commits for the core developers. The same was true for non-core contributors. So that's interesting. Does better testing lead to less smelly code? What do you guys think? Test-driven development? Hey, Ghost Magic, good to see you, man. That's true. As a core contributor, I introduce a lot because time is valuable. Nobody checks and I know I'll manage it. There you go. That Ghost, yeah. Spoken from someone who's done it. From Ghost, I mean. Open small requests. Within limits, TDD can be good. 100% agreed. Within limits, TDD, it can be good. It can save you a bunch of time. But there are some people who think that TDD is the end all be all, and you got to be doing TDD the whole way through, right? So let's get into it. For each week in a project's lifespan, we calculated the number of test cases available and the number of code smells in the code to check if there exists a correlation between them. We found that there is no statistically significant correlation between these two factors. Boom. Figure 9 shows the trend line found after plotting the normalized total count of test case and code smell count for each week for all projects. So test cases, regardless of their size or consistency, did not have a significant impact on whether or not you had a dramatic increase in code smells. As test cases are not created equal, we also wanted to check whether there is a correlation between test coverage and smelliness of the project. One sec, folks. Let me just drink something. My throat's getting hoarse. Now, we selected the last commit for each project and used the existing test suite for coverage analysis. Then for each code smell, we checked whether there is any difference between the low, less than 30%, and high, more than 60% coverage, measured using statement, branch, path, and mutation coverage criteria. Projects and number of code smells in the project. We found that for external duplication and internal duplication, low and high coverage groups have statistically significant difference in number of code smells present in the project. Okay, hang on. Figure 9 is a fallacy. The way they got the data is problematic. The way that they got the data is problematic. Is it? Maybe it is. We selected the last commit for each project and used the existing test suite for coverage analysis. Then for each code smell, we checked whether there is any difference. We found that for external duplication and internal duplication, low and high coverage groups have statistically significant difference in number of code smells present in the project. Okay, you might have to help me out. I'm having a hard time understanding exactly what's wrong. 6, you're making a good point. Depending on what they're testing for would also have an impact. I can agree with that as well. Figure 9 is a problem because I think they use projects with a bunch of different ages. This suggests the number of tests went up during a project, but instead it is the length at the end of each project. Right, but wouldn't the number still be the same if you're tracking the number of code smells introduced at a per commit level over the course of the project? Then the assumption would be that no matter how you got there, at the end of the project, the last set of tests you have at the end of the project should... No, wait, I think now that I've said it out loud, now I see the problem. You could have an increasing number of code smells because you didn't have a comprehensive test suite at any given point through the project. So like, imagine if you had a project where your comprehensive test suite only happened at the end. And so therefore you can look back at the project and go, well, of course code smells went up. And then you jump to the end and you go, look at this comprehensive test suite that you had at the end. Obviously it didn't matter for code smells. Oh, but wait, we didn't have this throughout the course of the project. So you would have to look at the test suite available at each commit. That would have been a more comprehensive way to determine whether tests had an actual impact. Fair. Good call out, Omni. Yeah, good call out. So it makes TDD hard to study. I mean, that would be tough, but I think based on look, the base of the study was that they went through each commit of 220 projects over the course of the project lifetime and determined at that point how many smells existed throughout the lifetime of the project. So you could, with a bit of effort, but not that much extra effort, look at the existing test coverage at that point, at that commit, at that point of the lifetime of that project, then compare test coverage versus number of smells at that commit point. And you could do that all the way across the project itself. And then you would at least have a more comprehensive comparison of test coverage to number of smells to see whether something like number of tests went up and number of smells went up, or number of tests went down, number of smells went up, or whatever the heck the difference that was, right? Instead of just jumping to the end and comparing. Indifferent Ghost, Omni, could you do me a big favor, Omni? I'm asking for a favor. Do you mind just dropping the link of this one because you already have it on Twitch chat? Otherwise, I have to go and switch over and copy the link and then put it into the chat, and you might have it. The one that we have on screen right now, if you already have it. If you don't, I'll do it. It's just it might be faster because I have to go I have to go over here and then crap. There. Maybe I beat Omni to it. But Omni might give you the original one. There you go. Thank you, folks. Thank you. Yeah. Okay. So Omni, that's a good call out. So I guess what we would have to say then, we would have to agree that but how would we... Wait, something doesn't make sense here then. Hang on. If it's true that they went to the end of the project to get the test case and then use that to determine the number of smells week over week, why is this a variable number? Wouldn't it be the case that the number of test cases would remain consistent? Oh no, this is because it's over all projects. It's over the course of all yeah, okay. So that's fine. So we just agree that okay, test cases, we can't really tell whether test cases had a significant impact or not. Literature versus real life. To answer our fourth research question, we calculated the number of smells being introduced and removed by category. This is a good one. Our goal here was to determine if there was a good match between the practices and problems real programmers deal with and the concerns of researchers. Figure 10 shows that SAP breakers, data class, and cyclic dependencies and feature envy were the most common smells, constituting almost 50% of the code smells being introduced and removed. Hot damn. So these two, SAP breakers and data class. Next, we looked to the research literature to identify which code smells receive most attention from researchers. We used the work of Zhang et al. And Soberg, I want to say, et al. Zhang et al. Performed a systematic literature review on code smells published in IEEE and 6 leading software engineering journals from 2000 to 2009. I think I actually have this study. I'm probably going to go over it in another stream. They identified 39 papers out of 319 papers that could answer the research question about which code smells received most research. Soberg et al. Expanded the analysis from 2009 to 2011. We ranked them up, and so here we go. Table 6. What is it? So data clumps rank 1 with highest frequency. Data class, and then so on. And so this is just like what's looked at normally highest in terms of like from a researcher's perspective. Okay. Oh, damn. Sphaerophoria, fellow Vancouverite, and working on some amazing Zig stuff. Welcome in, Raiders. Sphae, you're awesome. You are a legend. Let's get you a shout out. Thank you for the raid. I really appreciate it. That you did not have to do that, man. I hope you had a good stream. No, not I hope. I know you did, because I watch your streams often, and the stuff you do is like, it makes me feel like a script kiddie. You remember by the way, Freedom, welcome in. Any other raiders? Yeah, like the map stuff that you're doing. So, like, geez, and I'm using Zig just so the streamers, just so you know, be steady. Thank you for the follows. Faith, you got to go. I get it, man. Thank you for the raid. My name is Spiro. I'm a programmer, 20 some odd years, self-taught, no high school degree, nothing. I usually build a video game in Zig using WebAssembly. If you look back on some of my previous streams over the last few months, that's what I've been working on. And so then I run it on WebAssembly on the browser, just using like regular DOM, no canvas, no GPU acceleration, nothing like that. Because the entire intent of my streams are to show that the IT industry is in complete shambles. It's become enshittified beyond belief. We have been leaving a bunch of stuff at the door because we do not we have no idea what we're leaving on the table in terms of hardware and software. It's really, really bad. And so I was trying to show that, like, with Zig and WebAssembly and not cheating essentially, or not like using crutches and frameworks like React, which just make you more stupid and abstract away stuff that you should know yourself. And languages like Rust, which, by the way, I think Rust is going to implode in the future. It could take a few years, but it's going to implode. It's a piece of crap. We need to be doing better, or web and software is going to go the way it's going to become really, really bad. And so the last two streams I've switched over to actually gathering data, because I don't see anybody doing this. So when you watch Sphae, right, when you watch him, or someone like Travis, shout out to Travis, who I would put in the same sphere as Sphae. Honestly, seriously, guys, any raiders who are in from Sphaerophoria's stream, shout out to Travis. Let's see if I can even, if he's even on. He's not even on, but there we go. Follow Travis. Travis is writing his own game engine in C and Vulkan by hand. It is hey, com.8 and be steady again. Thank you for the follows. Essentially, if you want to watch like programmers who are going to make you feel like complete idiots, Go watch them. You're going to learn a whole bunch of stuff. And I put Sphaerophoria in exactly this domain. Anytime I go and watch Sphae or Travis cook, it's like, what am I doing with my life? I don't know. And we need more of that. That's what I'm trying to demonstrate on this channel. We do not know how good we have it. We do not know. I think we're being lied to a lot by things like, oh, you need to have something like React or whatever, because you need to have these crutches and, whatever it is. You don't. We can do a lot with very little. We just are so pampered and used to things. Go watch Sphae and Travis and you'll see how much they can do with very, very little. The problem is that when I have these debates with people on stream, it always devolves down to like my developer experience, my subjective experience, and people are trying to make like a persuasive, intuitive argument as opposed to a data-driven argument. I'm literally, the last stream and this stream, I'm literally pulling together weeks, months of research where I'm pulling in scientific studies that are like longitudinal studies, metrics, things like that, both directly within software and web and also kind of around it, that I hope piece together an actual foundational data-based argument as to why we are not doing well in the industry. And there are better ways to build software and build websites and build, apps and all of the things that we're doing that are more lucrative and more sustainable, and still they might ask more from developers, but developers will create code that is vastly different than the code we're creating now. So that's what I'm doing right now. That's all to kind of give you an intro for all the raiders. I'm literally reading very, heady, high level research papers. It's boring. It's not as exciting as watching Sphae build a map in Zig and try and figure out like how you would do like, like I was watching him do like some of the transit stuff, and like I want to be able to determine like distances between like where I walk and which transit line I take and things. It's not as exciting as that. Or watching Travis build his engine and then he like renders something in 3D. He's got like water rendering, I think, happening now. That's exciting. You watch that, it's exciting and it makes you feel stupid, right? It's great. It's not like that. But I don't see anybody putting attention on this. I don't see people trying to provide data, actual data, to make it more difficult for people to just come and argue, but my feelings though. Because I think we're in bad shape, right? So I am taking a hit. It might mean I lose a bunch of viewers, and I have a bunch of boring streams. But I'm taking a hit here, and I'm doing the hard work of putting the data together. And then what I've been doing is I've been putting my data on a website I'm running called enlightenedprogramming.com. And I'm creating articles along with these videos that I do. And I'm going to put a few of my research papers behind a paywall because it's taken months to put it together, and I don't see anyone else doing it. But I'll be doing the streams for free. So you can watch the streams and get all the information I have for free. And I'll only charge like $1 or $2 or something just to try and like, just to pay for my time, right? But what I'm hoping it'll do is it'll arm some people with the information they need to be able to make a case to others that changes need to be made in web and software. Okay, that's the spiel. Minnie, thank you for the follow. Owlman, thank you for the follow. Thank you for everybody who's joining in. Jonathan Blow is a great one as well. And Casey Muratori. And I've talked to Jonathan Blow and Casey Muratori on X like once. Just one tweet, like that's it. But I have also heavily reviewed some of their past videos, and Casey Muratori has some good articles on exactly this topic. He just didn't dive into it as deeply as I did. And I explicitly told them that I'm borrowing some things from their books. I did tell them that because they kind of paved the way for this argument. What I'm doing though is I'm diving deep into the data, deep into it. And I'm literally like, it's going to be as scientific as I can possibly think to get it, as this no high school educated person can put together, so that hopefully there's an impact on the industry in a positive way. Um, Real, I watch them and I feel stupid. Me too, Minnie. Yeah. Can we show the Raiders the 2016-2017 disparity? Sure. Yeah. I'll bring this up in a second. Let me just catch up on chat. Raiders, you're gonna like this. Hang on. Yeah, you can only watch past broadcasts. Yeah, watching live is a different experience. I agree. There are similar devs to watch. Alan Webster, Ryan Fleury also stream. They're really smart guys. I know of Ryan Fleury. I haven't watched him. I don't know of Alan Webster, but yeah, I mean, there's some good ones. What is my thoughts on data information theory? It has its uses. So look, like things like let's say LeetCode, which kind of has a basis on data theory or information theory and like data structures, how you approach certain problems. There are some positive uses, and there's definitely something that to be said for like understanding what those structures and mechanisms and algorithms and all of that, what they imply, their usages and what they imply. However, what they don't do is help you to determine when those things are applicable in practice. So here's the problem that I have with like studying these things in theory and then applying them. I find that people who actually go through the trouble of not understanding any amount of theory, but struggling, and I mean struggling through applicable scenarios and code where they end up applying the theory, they understand more about the theory than the people who have only studied it on paper, because they've gone through the struggle of the actual application and they've internalized it in a way that makes sense for them. So if you do that at an individual level and you multiply it by all individuals across the industry, and a subset of them actually understand the theory that they applied after they've struggled to apply it in a real world scenario, it's, in my opinion, it's more likely that you're going to get more developers who actually understand the theory at a deeper level rather than who have just read the theory and understand what's going on, right? And so I would say that it's almost like you should almost reverse it. You should almost have people who have gone through a bit of like programming struggles and, taken on some larger projects, perhaps. They don't even have to be like senior developers. They just have to have done enough and then go read the theories. And then you're going to be like, oh, holy crap, I actually use this. Or holy crap, I worked on something that like I should have used it, right? I think it would be better if people started from I need to go and like kind of feel my way around a bit, and then they reach a certain point where they go, okay, maybe I should read a few books or something, right? And then I think it would stick with them a lot better. Hey, Car, how are you doing? I do have a Discord. I'll show you my Discord here. There you go. You can join my Discord. Claude Shannon and information theory really changed the way I look at data. I'm sure they did, yeah. But at Freedom, I would say you probably had some experience working with something in the real world. Then you read those papers or the books and you could apply them internally a bit better, right? I heard the website he runs, Bo, was cooking. Does anyone have the website again? Enlightenedprogramming.com. Literally enlightenedprogramming.com. I'll put it in chat here. Enlightenedprogramming.com. There you go. So like the last stream, which I haven't been able to turn into an article yet because it was only 2 days ago, this stream, I'm essentially going to condense it so that the parts where I'm talking with you guys aren't included. It'll be more just me sticking to the data and the numbers and going over it. And then it'll be both the stream condensed in video form along with a written version of it. So you can do either or. And then I'll include some extra things that I don't include on stream, on purpose. So that if you're going to pay $1 or $2 to get it, then you're going to have a little bit of extra. It's an incentive. So it's not just what's on stream in written form. It's also what's on stream in written form and with some extra things that I purposefully set aside so that I can provide a little bit of added value if I'm going to ask for a little bit of money for the work I'm doing here. This is tedious, boring work, honestly. I'd rather be coding my WebAssembly game. Seriously, it's way more fun. But I just care about this too much. I can't, nobody else is doing this. Nobody else is even trying. So fine, I'll do it, But anyway, Carlos HSS _ thank you for the follow just now. And if anybody still here from the raid too who wants to say hi or whatever, please say hi. In different ghosts, it's been shown that trauma increases memory retention. With some of the papers I've read, implementing them would be trauma. Yeah. I think there's a study. I think I have it on my list of studies that I'm going to look over. I believe that there is a study that did set out to prove that a higher friction workflow in terms of programming leads to an outcome of better quality of code. I can't remember the reasoning why, but yeah, it was something like that. Hey, Magic Food Hand, raiding with a party of 5. Welcome in, raiders. Magic Food Hand, you get a shout out, man. Thank you for that. Welcome in, raiders. I just went over a big spiel of what I'm doing. I'll do it one more time. Saw the title and couldn't resist. Okay. Well, Magic, I hope you had a good stream. I know sometimes you got to raid and run. I get it if you got to do that. My name is Spiro. I'm a 20 plus some odd year developer, self-taught, not even a high school degree. I do mostly web development. On the stream, I've been building a video game using Zig, which I compile to WebAssembly. And then I run it on the browser with just DOM elements, no GPU acceleration, no canvas, nothing, no cheats. All for the express purpose of demonstrating that we're being lied to in the software and web industry. Things are not as bad as people say they are. In terms of like our capabilities, we can do a lot more with very, very little. We just choose to make complications for ourselves, and we reach for stupid things like React or Rust or whatever because we think that they're going to solve problems for us. But what's ended up happening is that we've actually caused more problems over the long term than we've solved over the short term. The issue is that when I present this argument, it always devolves into, but my feelings though, my developer experience though, look what I can do with my libraries and 100 different dependencies and all of that. I can do a lot more than I ever did before, yada, yada, yada. There's no data. So even though I would very much like to be working on my Zig WebAssembly game, because that sounds much more fun, it is much more fun. And I even made it multiplayer with Twitch chat and everything. I don't see anybody looking at actual data to make the case that basically the IT industry is just basically a heaping pile of shit right now. It's all just feelings and subjectivity. That's all it is. Nobody can actually present actual data that even partially indicates that things are not the way they should be. So as boring as this is, last stream and this stream and several future streams are dedicated to going over this data, because I want to make a data-driven argument that we need to be doing better. And so what I have on screen and a few studies are what I've been going through on this stream today, and then I put them all on my Enlightened Programming website. It's enlightenedprogramming.com. And I have articles. So I do the stream, I condense the video, I put it up as a video, and then I put a written version of it. And then in a bit, what I'm going to do is because this was months of research, I'm going to start putting some of these behind a paywall, like for like $1 or $2, because it's a lot of work. And I don't see anyone else doing this. Literally no one else is doing this as far as I can tell. And I'm hoping that by doing this work, people will be armed with the ability to go and make the case that we need to be attacking our code, web and software, in a very different way than we're building it now. And hopefully even people who are not programmers, like business executives and whatnot, will see that the data, because I think I have data to prove that if you approach the programming paradigm differently than what we're doing now, you can make a lot more money over the long term than the short-term money that you're trying to get by focusing on the next quarter and getting to that exit. There's way more money to be made by actually struggling through writing quality code the way that it's meant to be written. And we're doing a really shitty job of maximizing with the stuff that we have available to us. So to that end, CVE stands for Common Vulnerabilities and Exposures. That's right. A Buff Siegel, thank you for the follow. Magic Food Hand, again, thank you for the follow. Vulnerabilities are common in C-based programs, though. They are, yeah. Theo is making a similar argument. I think I know him. Yes, you're talking about T3. That's right. No, I actually disagree. I don't think T3 is making a similar argument at all. As a matter of fact, I think Theo is making the argument that certain web frameworks in particular are kind of like a panacea to the issues. I actually don't think I think from his perspective, he might agree with me, but I think in action, the things that he promotes to the people who watch him are antithetical to the premise that I am making, whether he agrees with my premise or not. So in practice, I don't think he agrees with me, but maybe in words he might. Dojo, thank you for the follow. Somebody, I think Laugh earlier, was shocked by the numbers. This is something we looked at already, but for all the raiders who have come in, take a look at the CVE report. This is one of the most damning things I've showed on stream so far. If we go look at, let's go look at this. So we'll go here. We'll go oldest to newest, okay? So have a look. Let's start over here. Have a look at like the last few years. Let's say from 2017 to 2023, because 2024 isn't over. So have a look at the number of vulnerabilities that are being reported this is basically like, I would say it's the de facto place where you would report vulnerabilities. In 2023, we had 28,961. Compare that to 2017, sorry. We're almost double in about 5 to 6 years. And this includes software and I believe web as well. This is kind of a catch-all. Now look at 2016 to 2017. Something happened where it doubled again, more than doubled. And it's not just here. On the last stream, which I think is still up on my Twitch and my YouTube, we went over this data, but for the web, only for the web. Handy Meow, thank you for the follow just now. I appreciate it, man. We went over this data, but for the web, and we looked at what was it? It was oh man, I'm sure I could find it. Essentially, it was web metrics. So what they did was they would take year-over-year metrics of things like number of JavaScript files that were requested on average, given all the like hundreds of websites that they studied, or the average size of the JavaScript payloads, or time to first paint, first contentful paint, number of CSS files, size of CSS files, like all of these factors that go into websites year over year. And we noticed something that was also quite startling that matched up with this today. In 2016, 2017, the web also took a massive upshot like this, exactly like this, around the same year. And CVE, as an independent source, seems to correlate this upshot. And you'll note that ever since then, we have done nothing but go up and up and up. Now, if you go back from 2017, and let's just go back 10 years, from 2007 to 2017, there is also a big difference. 7,322 in 2007, 5,673 in 2008. So we went down, then we went up by about 100, then we went down by almost 1,000, then we went down again by almost 500, then we went up again by about 1,000, then we went down by 100, then we went up by almost 2,000, then we went down by like whatever this was, 1,800 or something like that, then we went down just a little bit. So like what was going on here where the variability was, well, like it's stable AF, right? Then 2016, 2017 comes along and everything goes to shit. And this is exactly demonstrative of my entire argument. And I think Laugh on my Twitch chat called out correctly that I need to be looking, because if CVE says this, and if the web metrics says this of the same years, then I need to be looking at what the hell was going on in 2016, 2017. And one of the things that I think took off in 2016, 2017 was React. But I'm going to go and prove this. And if you look back even before, here's 2007, right? We started there as the second set. And if you look back here, look at what was going on from start to, like, you know, even across the years here. Something happened in 2004, 2005. What could have happened here? That part I'm not sure about, but I have to go look at. But even if we just exclude, let's just say we just look back no further than 2005, right? You can still see how in 2005, things are pretty damn stable. And then they're not. It's freaking Ethan. Hey man, CVE includes firmware too. Lots of stuff that's 20 plus years old, and end of life gets CVEs to this day. I think your argument might be flawed by the fact that more is being found because more is being looked for. Respect for having a unique stance on this though. That's fair, Ethan. But I would also argue that that it's not just that, right? We do have lots of software being built that has a shorter time frame than firmware. We have lots of websites that are being built that has a shorter time frame than just firmware. And if you look at if you could take that shorter time frame and you look back, even just say, let's just say we go like 2012 onward, there is something that's not right about the numbers. Right? There's something that's not right about these numbers. I mean, definitely wonder if CVE's website shows web vulnerability. I think it does. It's a big leap out of nowhere. I doubt it would just be firmware. I doubt it's just firmware. But I would say, Ethan, it's a factor, but I don't think it's such a significant factor that all of a sudden in 2017, all these firmware things just suddenly popped up out of nowhere and started causing problems. Oh man, on Twitch, Twitch ads. I'm going to pause for Twitch ads. Sorry, folks. Pausing for Twitch ads. Stupid Bezos. Hey, Travis. So while Twitch ads are up, by the way, if you're not following Travis, you should be. Travis, I gave you a shout out earlier. Let me see if I can find web metrics. It would have been what, like JavaScript requests, I think. Metric Insights, is this it? No. Yeah, man, anytime. Request metrics? No. Where was it? Let me go see if I can find it. Since Twitch ads are playing, I'll let the Twitch ads finish. And I'll go over to my thing here. Let's go see. Where are my things? They're here. And if I go down to my notes and I go see where's my web data, blah blah blah. Here, it's one of these. Here it is. Found it. We were remembering how LeetCode you code. Yeah, Travis, I put you in the same vein as Spheriphoria because watching you guys code makes me feel like a dum-dum. Okay, so it was this. So we were looking at like, let's say total kilobytes, just to see, since Twitch ads are playing for another 30 seconds or so. Let's see if we can correlate this with the CVE data 2016, 2017. So if we went, well, I guess we can just keep it like this, right? So let's go down to 2024. We're going to go by total kilobytes. Let's just see if there's like a marked increase. So nothing too big in terms of... Hang on, I got to go back. Here, where are you? 20. Why are you doing this? No, you would go all. Is that it? Really? Yeah, it only goes back to 21. Let's see. Why does it only go back to 21? I thought we were looking at way more before. Let's just try. Let's just try doing this here, and we'll go to like the end of, I don't know, we'll go to like sure, 2018. Okay. No, it's still, oh yeah, there we go. There's like no data. That's why. It actually doesn't have any data. So what year was it that we were looking at where there was that sharp increase? I don't remember. I don't remember. Anyways, it's okay. It's okay. If it's not here, I think there was somewhere else I found it where I can... Yeah, it's just that it's not pulling in the actual data from this 2016. Yeah. But this one doesn't actually have 2016, but I know one did. I'll have to go back. Okay, so where I was leaving off was we read this study, and it talked about code smells across 220 projects on GitHub, and essentially the code smells were bucketed into bugs versus design issues, and whether code smells went up or down on these projects, and they went up, like high, very high. On average, they increased by a lot. Hey Frackery, good to see you, man. Hey Vicente, good to see you. So then essentially the conclusion of the study. So now that the Twitch ads are done and I've got the raid stuff out of the way, let's finish this off. During our analysis, we found that the overall number of smells increase over the life of open source projects, as shown in Figure 2. This is not to say that issues of design or technical debt are not addressed over the life of the project, but as Figure 8 shows, it is simply a matter of new issues being introduced faster than old ones are resolved. How is this not what happens even in closed source corporate environments? More importantly, as is also evident from Figure 7, the pace of smell introduction accelerates over the life of the project. This one, I think this is probably one of the most key sentences in this whole study. The amount of smell that, if you want to call it smell, because I know like a lot of people don't like the word smell because it's too like all encompassing. But as the project increases, we all have this like original idealistic view from developer to executive where it's like, it's okay, we'll set aside the time in the future, we'll spend the money, we'll pay down our technical debt, and we'll get it right. It never happens. That shit never happens. House always wins. This could be an artifact of either projects adding new developers over time, thus having some of the initial core design knowledge watered down, or that as projects progresses and code builds up, it becomes increasingly difficult to unravel fundamental design revisions, or that an artifact of bad design decisions leading to further compromises. While further research would be needed to look into the nature of smells added and removed, we find it likely that there is an element of all three dynamics at play here. Most likely, yes. Next, we looked at the types of design smells being introduced and found two general patterns. Those smells that more or less monotonically increase over the life of the project, and those that plateau at some point. For the monotonically increasing smells, the analysis seems straightforward. Some mistakes are made throughout the life of the project, or some compromises in design breed other similar compromises to be made later in the code. This is almost word for word what I've been saying on my first mother effing stream. It's an easy button. As soon as you see a door and it says easy on it, like React. As an example, I like picking on it because it's easy, although React has its use cases, okay? But generally speaking, as soon as you go, well, we're just going to compromise here because it makes our life easier. It makes our subjective developer experience easier. You open one door, then you're inside the house. Then you go, well, the door's already open. Why not just open another window? It's one window and a door. And then now you've got a window and a door open. And then you go, well, we've opened this much. Why not just open up another one? And then so on and so on. And pretty quickly, you've got everything open in the house and everyone just walks in and takes whatever the hell they want. Most likely, though, these represent self-reinforcing patterns with projects. We've used this structure or technique elsewhere in our code, therefore, it is okay to do so again. As a code base grows, this can have serious consequences. As previous research has shown, a correlation between smelly code and maintainability and bugs. All code smells in the bloating category show a growing tendency. This category is associated with centralized control structures in object-oriented languages. Aris-Holm et al. Found that novice developers perform better with centralized control styles. It is therefore possible that novice contributors are pushing for these changes, or that they are being introduced by regulars to make it easier for newcomers to participate. This happens all the fucking time. And I don't care what you say. If you look into the history of a lot of frameworks that have come out, fine, React is one of them, but I'm not just going to pick on React here. But there are quite a few. Way more often than not, a vast majority of these libraries and frameworks and even languages, what they do is they cater to the lowest common denominator. What they're trying to do is go, oh, you don't want to put in the time and effort to get the knowledge that's required to actually work with a code the way that it's intended to work at its most performant, or its most optimized, or its most efficient, or whatever. Don't worry, I'm going to build a layer of abstractions for you so that you don't even have to worry about it. All you have to do is trust that smart guy over here did the thinking for you, and as long as you check off these boxes, you're smart too, and you can do just as much as I can, even faster than I can, because I already did the heavy lifting for you. But we can see here that this kind of thinking permeates in open source, and it doesn't mean that things get better. My argument, which is what I'm trying to make with all these studies and the streams, is that it makes things worse, that we shouldn't be catering to the lowest common denominator. Yamashita et al. Found that a considerable portion, 32% of developers, did not even know about code smells, and only 4% use specific code smell detection tools with refactoring tools to remove smells. And you could even say this about test-driven development or other types of bug identification systems. This could explain the monotonic growth. Once a smell is introduced, it's unlikely to be identified or fixed. The more interesting pattern is that of the smells that plateau or even decrease after an initial spike, which included many of the smells in the OO abusers category, these smells are indicative of poor and unsustainable designs. One possible interpretation of our findings is that they may represent acceptable compromises for prototyping and getting something out the door quickly, but that these design patterns likely present serious roadblocks to the future growth and success of the project. Fuck me straight in the urethra. How many times has this not happened in your experience, in my experience, in actual real world projects where you go, we're going to prototype, good enough, ship it. Straight in the urethra. Developers facing such a situation are forced to refactor the code, and moreover, according to Yamashita et al., developers are more aware of this type of smell, which likely leads to increased refactoring. On the other hand, this pattern could just as easily be caused by projects making all the OO design decisions early in the project's lifecycle, with few, if any, such smells being added over time, because no OO design changes take place. The slow increase and then the dipping pattern seen for internal and external duplication in the dispensables category might be caused by developers working under constraints such as imposed deadlines or lines of code-driven performance evaluations. This kind of hints at something that I also have a opinion that seems to be the kind of a hot one now. I had it before it was hot. The agile methodology in full force is the stupidest methodology you can use to try and help your programmers, like encourage them to do better. You're just treating them like kids, and all you're doing is abstracting away the management level and making managers be able to wash their hands of shitty code by saying, well, I as a manager checked off all these agile methodology checkboxes, therefore any failure of the project is not my fault. It's the fault of the programmers. Another reasonable circumstance where developers duplicate code is when they do not fully understand the problem or solution. Duplication becomes a safer way of modifying code rather than generalizing. As a code base grows, it eventually becomes difficult to add new functionality, and developers are forced to refactor and remove duplication. Furthermore, developers are aware of code duplication and its consequences. Yamashita et al. Found that duplicate code was the most mentioned code smell in their survey. This can also explain why duplicate codes are refactored more often. We do not really have data to support this, and further research is needed to fully explain such trends. We also found that some smells are essentially added and removed on a near constant basis. In the dispensables category, for instance, the data classes code smell was already found by Combe et al. As one of the most change-prone code smells. Possible reasons for such behavior is that coders are either unaware of the perils of this design pattern, or that when coding, they do not realize when they are violating such design practices. Disconnect between theoretical knowledge and practical. What did we just talk about before I got into it? Just now, with some of the new raiders. By the way, again, just want to say welcome into all the new viewers. We literally we were talking about like Shannon theory, right, and data and information theory, and this is what I mean: is that there's a disconnect between the theoretical knowledge and the practical, and you need one and the other. And my argument is that you actually need some practical experience first. Then you can go into the theoretical, and you'll understand it at a much deeper, better level. You'll be able to internalize it much better, rather than going into the theoretical knowledge first, thinking you know everything under the sun because you have a certificate behind you, but really you're just a dum-dum. And then when you go to do it in practical mode, you're like, what the hell am I doing? That's not always the case. There are exceptions to the rule. There are lots of smart people out there, okay? Some of you are in the chat, okay? I'm just saying as a general rule. This to us is a clear sign that we need to do better integrating smell analysis either into IDE environments or into repo tools. So essentially what this paragraph saying is like, we have to, developers need more tools and to actually use them so that they can actually determine, have a better understanding of what's going on and a better chance of fixing it. We did find that core developers introduce both more smells and smell fixes than non-core developers. Not an unexpected finding given core developers' predominance in the world of coding. What was interesting, though, was that core developers were no more likely to fix code smells in proportion to the size of their contribution than non-core developers. This was a surprise to us, as we expected core developers to have a better understanding of both the software's high-level design and of best coding practices. This turned out to not have a significant impact on the outcome of their coding. While difficult to interpret, this leads us to think that even among core contributors, understanding of high-level design trade-offs and or the time to refactor code may be in short supply. So imagine what this might mean, even if it's only partially true. Out of 220 open source repositories that were studied, at least some portion of them had high-level core contributors who could not understand what was going on under the hood. We also found that the number of test cases does not show any correlation with the design quality of the project, although Omni already called this out as being like the data that they did, the way that they grabbed the data for this was bad. So I'm going to skip this, not as valid. We found that most of the code smells that were ranked high by our analysis were not highly ranked in the research literature, with the exception of duplication. In other words, here's what this means. And this is why I've had one hell of a mother effing time finding actual data to represent the point that I'm trying to make, which is the enshittification of software and web. The reason why is because the research data has a different focus than the actual problems. That's what this means. So the code smells found in this paper are not representative of the code smells that were focused on by other research in other related literature. That means if you're looking at real world problems like I am and trying to figure out whether the real world problems have any scientific basis for actually being real world problems, or if they're just subjective, whatever arguments, good luck finding the data. That's why this has been extremely difficult, and it's been painful and tedious and boring as hell. I'd much rather be coding my game right now. While understandable to a certain extent, common problems are not always interesting problems. This shows a divide between the world of theoreticians and practitioners, again a disconnect between applicability and theory, which may further drive the latter away from tools and practices we in academia try to promote. More attention should be paid towards analyzing the impact of high-frequency real-world smells and making the tools more efficient in identifying these. Alignment between the research and real-world smell is necessary for making code smell analysis acceptable to everyone. And if you don't like code smell, it could be anything like number of bugs, etc. And I do actually have some studies that tackle number of bugs. So they do their due diligence for the most part and provide like potential holes in the study. So they're looking at open source GitHub contributions. You know, you could say like, well, it's not representative of things as a whole, which it's not, and that's fair. The number of commits, the number of projects, whether contributors were like changed, number of contributors as they went up and down throughout the project, their tools, frequency, things like that, right? So, and then they just do another conclusion at the end. So that's it. That was one study, and I have several more. Actually, I have a lot more, to be honest with you. It's gonna take quite a while. Dwayons, thank you for the follow on Twitch just now. I appreciate it. Do say hi if you're here. If you're doing a flyby follow, thank you anyway. Yeah, it only covered open source projects, 220 of them. I see chats going crazy, which is good. Yeah, autocomplete. Yeah, I mean, there's data class is just a struct. What's wrong with that? Well, it depends, because a smell is not necessarily like a one-to-one relation to like there's an issue here. A smell is like there's the reason you're using this here should be questioned. So if you're using a struct, it's not that you used a struct and it's wrong. It's that you used a struct. You should be wondering whether you should have. That's more of like what it's a smell is an indicator. So I think the reason why they call it a smell is because it would be the same thing as like you walk into a room and it smells like shit. And that doesn't mean that you shit in your pants. It just means that there's like shit in the general vicinity. That's what that means. So you just kind of have to ask the question, did I shit my pants? That's the question you're asking. I better check and make sure that I didn't shit my pants. And then if you look and you didn't shit your pants, okay, like that's fine, right? It's counting structs as that's yeah, correlation is a tool, not always bad, but may indicate a coding tendency. Right. It's a corollary. That's right. So if you're using code smells, and so here's the thing too, right? And this is why they looked at number of code smells introduced versus number of code smells reduced. And the reason why they did that, so let's go back to the numbers up here to the graph. It would be, where was it? Where are you? Here. So if you look at this, the reason why they do introduced versus reduced is because there's it indicates that if you're going to reduce code smells, that maybe the thing that smelled was actually a problem. Therefore, you removed it. So even like that's why I think earlier, I don't know if you caught that portion, but earlier I took some of the numbers that they had and I went like even more conservative. I said, what if you just like took those numbers and you just said they were 50% wrong? And that's what the gray error bars here also include. They include like an error rate, like max error, lowest error, max error, lowest error for both introducing and reducing. But you can see that even when you include the lowest possible number of introductions to the highest possible number of reductions, there's still a marked disparity. And the fact that they're doing reductions means that there are smells that do have issues. So there's a corollary to be made that's not entirely off the mark. Hey, Pierre, how you doing, man? Okay, so that was one study. So that was that one. And then I think it's this one. So then we have refactoring on code smells. So this is why I kind of structured the studies this way, because now we can kind of just skim over the last two here because we've already done a bit of the heavy lifting. So this one is kind of like the next step from the last one. If you have code smells, you're going to want to refactor. So if a code smell means that you have a problem in your code base, then a portion of fixing that is refactoring the code smell, right? And so the question would be, does refactoring actually have an impact on the smells or the problem that you're trying to solve? And so we can kind of skim over some things, but essentially, code smells in a program represent indications of structural quality problems, which can be addressed by software refactoring. However, refactoring intends to achieve different goals in practice, and its application may not reduce smelly structures. Developers may neglect or end up creating new code smells through refactoring. Unfortunately, little has been reported about the beneficial and harmful effects of refactoring on code smells. We analyzed how often commonly used refactoring types affect the density of 13 types of code smells along the version histories of 23 projects. Our findings are based on the analysis of 16,566 refactorings distributed in 10 different types. Even though 79.4% of the refactorings touched smelly elements, 57% did not reduce their occurrences. So you can kind of infer a few things from that. It's not necessarily that all of them actually should have been reduced. What if it's a smell that didn't actually mean anything? Surprisingly, only 9.7% of refactorings removed smells, while 33.3% induced the introduction of new ones. More than 95% of such refactoring induced smells were not removed in successive commits, which suggests refactorings tend to more frequently introduce long-living smells instead of eliminating existing ones. Okay, now let's be a bit aggressive here, right? Let's say that they're making like a bad assumption. Let's take the numbers at face value. So let's say it's 16,566 refactorings, right? And 79.4% of refactorings touch smelly elements, but 57% did not reduce their occurrences. Well, what if a vast majority of these occurrences didn't actually need to be removed at all? What if it was just a smell? What if you think you shit your pants, but you didn't actually shit your pants, right? You don't account for that, right? You're just assuming that because it smells, you shit your pants. So I don't see this as being like as a nail in the coffin, so to speak. But let's just assume for a moment that even like only 10% of the occurrences had to actually be removed. That still tells me something. I'll leave it to the end. Let's just get through some of the numbers because this still tells me something that the article itself does not tell you. A lot of refactorings are happening, right? So then they go look at like what kinds of refactors there are. Examples of smells like God class, long method, speculative generality, refactors such as extract methods, move method, pull up, extract superclass, extract interface. Okay, so they do all that. They go look at like what mathematical equations would apply to how they take the numbers that they have and then like apply them, right? And so then they go look at the different projects, so you can see which projects they looked at, lines of code and commits. Okay, like fine. It's a reasonable like mix of things. I don't really have much of a issue here, right? And then they go look at like the different code smells. Okay, sure. And then they go look at the types of refactorings, and then they apply a like formula of the refactoring, the type of refactoring, whether it had a neutral, negative, or positive impact in terms of smell changes, right? And so then what they did is stinky refactorings, which would be like refactors that introduced more smells, removal versus non-removal, all that stuff. Okay, so here's why I bring this one up, because I don't think that it's a very solid, like, for what they're trying to explain. I don't think it's solid. But there is a tidbit. There is a tidbit that I think is in here, but it is not mentioned in here. If we go back to the top, I'm going to read it out and then I'm going to give it in simple terms. Our findings are based on the analysis of 16,566 refactorings distributed in 10 different types. 33.3% induced the introduction of new smells. What that tells me is that a non-0% of these refactors introduced at least some bugs and some design issues that did not previously exist. And in my view, this is something I'm going to get to. The reason why I'm saying this right now is because I already have this data planned out ahead. So I'm trying to kind of like lead the next few streams. In my view, a proper refactor, has to have two factors in it. One, it's supposed to be a replication of business feature requirements. Two, it's supposed to take the things that didn't work in your current implementation of business feature requirements and make them better. And if refactoring, even in a not so great study like this, tends to lead to more code smells, and if a fraction of those code smells are legitimate design and bug issues, then that tells me that refactoring is not producing the intended result of refactoring. And that all too often, this refactoring falls into the same idealistic view that we have of a bunch of other things, where you go, oh, but if we refactor, we're going to solve a bunch of problems. No, I don't think you are. I think more often than not, you actually introduce new problems. And it might not be a significant amount, but you're still introducing them more than you're removing them. Okay, so that's one. I just kind of wanted to kind of briefly touch on that one. And then just kind of like a general study, just to kind of tie this off, a large-scale study of programming languages and code quality in GitHub. And so what I liked about this one is that they did a very large study on GitHub to determine whether languages and things like static typing, strong, weak, dynamic typing, things like that had an impact on the code quality, and what does code quality mean. Now, I also am not actually convinced that this is a very strong study given the methodology they used, but I do think that there are some insightful things in the study that we can kind of extract from it, and this will be the last thing I look at for the stream. So just one sec. I gotta have some more coffee here. Man, all this talking. Listen, a few W's in chat for me for being the guy who's falling on the sword here. To do all these, to reading all these studies and reading all this data and putting it together for you so I can try and make the industry better so we can all make more money. W's in chat for me, okay? No one else is doing this for you. Okay. So, what is the effect of programming languages on software quality? Thank you, folks. Thanks, Al, man. Literally, I do not see anybody sitting down on stream and going over scientific studies to try and prove an argument, and the argument being we can all make more money and do better software and web. I just don't see it. At least I'm trying. Even if I'm wrong at the end of the day, at least I'm trying. This question, okay, blah, blah, blah. Okay, so in the study, we gather a very large data set from GitHub. This was impressive. Thanks, Travis. Appreciate it, man. 729 projects, 80 million lines of code, SLOC, I think single lines of code, 29,000 authors, 1.5 million commits in 17 languages. If nothing else, just those numbers alone are impressive for this study. This reasonably large sample size allows us to use a mixed methods approach, combining multiple regression modeling with visualization and text analytics to study the effect of language features such as static versus dynamic typing, strong versus weak typing on software quality. Okay. So essentially, we report that language design does have a significant but modest effect on software quality. Most notably, it does appear that strong typing is modestly better than weak typing. And among functional languages, static typing is also somewhat better than dynamic typing. We also find that functional languages are somewhat better than procedural languages. Man, where's Tej, you know? Where's Leo? Who else? Mulroy? It is worth noting that these modest effects arising from language design are overwhelmingly dominated by the process factors such as project size, team size, and commit size. However, we hasten to caution the reader that even these modest effects might quite possibly be due to other intangible process factors. For example, the preference of certain personality types for functional, static, and strongly typed languages. Right. So then what they do is they go into a breakdown of their like methodology and languages. So we choose the top 19 programming languages from GitHub. We disregard CSS, Shell Script, bad cop would not like this, and Vim Script, as they are not considered to be general purpose languages. Oh, damn, shade thrown. Oh, I want to... Oh, I got to put that. Hang on, I got to put that on X. I'm putting it on my X. Shade thrown. There we go. There it is. I like it. Okay, back to this. We further include TypeScript, a type superset of JavaScript. Then for each of the studied languages, we retrieve top 50 projects that are primarily written in that language. Table 1 shows top 3 projects in each language based on their popularity. In total, we analyze 850 projects spanning 17 different languages. So here we go. I'll just zoom in on this, but you can see what they pulled. So they've got C. They literally looked at Linux, Git, PHP source, C++, Node WebKit, PhantomJS, Mongo, C# mentioned, Objective-C, Go, Java, CoffeeScript, JavaScript, TypeScript, Ruby, PHP, Python, Perl, Clojure, Erlang, Haskell, Scala. Okay, so not bad. Except that for TypeScript, look what they looked for TypeScript. Remember? Boys, do you remember? Dojo, how did they measure or define quality? Also, too large of a sample is bad statistical practice. If you're capturing a lot of experience, your study is flaw. I'm a math guy. I guess we're going to get into we're going to get into what they consider quality, and we'll see, because I'm not sure that I agree with their definition of quality either. So they retrieved the popular projects, then evolution history. And so you can see that what they did is they looked at like overall history so that they could kind of determine which projects had a overall history that kind of like lined up really well with the kind of study that they wanted to do and the data that they were looking for. So, okay, like not bad, not bad. Then they categorized the languages. And so you can see they did things like procedural, scripting, functional, static, dynamic, strong, weak, managed, unmanaged. Also good. I think this is a good thing to do. The project domain, also a good thing to do, right? That way, if you're going to look at the data, you can kind of break it out by kind of like these domains and types. I do like that. Then they categorized bugs. So while fixing software bugs, developers often leave important information in the commit logs about the nature of the bugs. For example, why the bugs arise and how to fix the bugs. We exploit such information to categorize the bugs, similar to Tan et al. First, we categorize the bugs based on their cause and impact. So root causes are further classified into disjoint subcategories of errors: algorithmic, concurrency, memory, generic programming, and unknown. And then they break it down even more. Keyword search. This is one of the things that I thought was kind of iffy. We randomly choose 10% of the bug fix messages and use a keyword-based search engine to automatically categorize the messages with potential bug types. I mean, I don't really know if I like that. It kind of sounds to me like somebody could, like, you couldn't exactly tell where a bug fell into, and you maybe you didn't have the expertise on hand in the study to determine it. So you kind of made like, you kind of had to bucket them. I can understand why, if you don't have the expertise to actually like determine these things, you might choose to make this approach. But I find this approach a bit like there's a crack in the armor here, right? And this is probably just one of a few. So then they go on to talk about bugs, and then they go and they categorize them in terms of the proportion of precision versus recall, right? So like what kind of bugs they are, and whether or not they appear again, or whether they get fixed, etc. Right? And so you can see the breakdown. Concurrency being, it looks like concurrency is like the highest one. So then they go through their statistical methods, and so you can see in terms of bugs, etc., what they go through. So let's just have a look at some of the warnings. So I remember reading this part. So there are some differences in terms of, are some languages more defect prone than others? And you can see there's some deviancy numbers here that might like indicate that there would be, right? So down here, right? You might look at these numbers, and some of these numbers might be like, oh yeah, clearly like something is objectively better than the other thing. However, they do make an important note that I think is important. One should take care not to overestimate the impact of language on defects. While these relationships are statistically significant, the effects are quite small. In the analysis of deviance table above, we see that activity in a project accounts for the majority of explained deviance. So it actually isn't so much the language that's being used, although it has some impact on whether or not there are defects in the language. It's actually more about the activity. And that kind of makes sense to me, because the more activity you have, whether you have a good language or a bad language, you introduce like a higher set of code changes or code numbers or whatever, lines of code, where defects are more likely to appear, rather than a probably more consistent rate of defects if you introduced very, very little and you just accepted whatever defects came with the language itself. So, that's an important thing to note. So then some languages have a greater association with defects than other languages, but the effect is small. So that's kind of like their first result. Which language properties relate to defects? So now we're looking at like language properties. So then you can look at things like defective commits, for example. So what they would do is I think what they did is they went through commits done for each project, and they determine which commits of which type, and they put that in a bucket, like type of commits, and then they determined whether that commit led to a bug or a defect. And so then what they could do is they could provide a number that looked at essentially the type of defect, so defective commits, and then how they impacted the number of defects that came out, overall. So you can see things like log commits versus, say, proc static strong managed, procedurally static strongly managed. I think that's what that would mean, and then functional static strong managed, right? Like there's a difference there, right? So then in terms of results, there is a small but significant relationship between language class and defects. Functional languages have a smaller relationship to defects than either procedural or scripting languages. And you could probably come up with a few reasons why that would be the case. Does language defect proneness depend on domain? So the middleware domain, JavaScript, is the most defect prone, 31%. This was little surprising to us since JavaScript is typically not used for middleware domain. On a closer look, we find that JavaScript is only one project, V8, in middleware domain that is responsible for all the errors. That's pretty damning. Also, Scala is the most defect prone in the application domain with a defect density of 52.67%. However, a single project, Zipkin, with defect density of 80% contributes to most of the defects. Similarly, Perl and C are the two top most buggy languages in database domain, with defect proneness 58.63% and 61.47% respectively. However, we find that the MySQL project is solely responsible for such a high defect count, where overall defect density of MySQL is 70.25%. Thus, it turns out the variation of defect density of the domains with languages may be an attribute of individual projects. And so then they took an approach to try and filter that out to see could they filter out individual projects versus not. There is no general relationship between domain and language defect proneness. It's probably more related to the project itself and the nature of the project. So even though you could look at a statistic to say, oh, look, this domain is sucking, it actually might not be. What is the relation between language and bug category? So then they describe what they use for that. So here you have the bug type versus the class, like the type of code base that they're looking at. So you can see the strength of each bug type given the type of class of programming language. So some of them are clearly going to lean more towards a particular bug type than others. And you can see that the functional languages kind of have it better overall, I'd say. Kind of have it better. But I think there's some that stand out here and some that don't. And then you have programming errors. So they define what these are. There's programming errors. There's so then they go, generic programming errors account for 88.53% of all bug fix commits and occur in all the language classes. For example, we find 122 runtime errors in JavaScript that are not present in TypeScript. In contrast, TypeScript has more type-related errors since TypeScript compiler flags flag them during development. Memory errors account for 5.44% of all the bug fix commits. Right? And you can see, this is kind of interesting. You can see the type of the language versus the type of issues that the language has. C, taking the lead on memory. Well, let's have a look at like what would be the worst offender. Maybe Go on concurrency, perhaps. If I'm reading this right, it might be the other way around. But yeah, like, yeah, I can actually kind of see this being generally true. I can see why JavaScript will lead to more particular types of errors than TypeScript, and TypeScript will lead to other types of errors. But this is an interesting one. Though Java has its own garbage collector, having a memory leak is not surprising since unused object references often prevents the garbage collector from reclaiming the memory. In fact, we notice 28.89% of all the memory errors in Java come from a memory leak. 1.99% of total bug fix commits are concurrency errors. And then they break down the languages that have almost a direct effect on this. Around 7.33% of all the bug fix commits is related to impact errors. Among them, Erlang, C, C++, and Go produce more security errors than average. This does not surprise me at all, actually. Defect types are strongly associated with languages. Some defect types, like memory error, concurrency errors, also depend on language primitives. Language matters more for specific categories than it does for defects overall. Then they cover related work, probably stuff they've referenced, and then they make some small conclusions, which we've already covered. So that's the kind of the last thing I wanted to touch on this stream. I think the chain of studies that I went over from beginning to end of this stream are at least an attempt to gather some actual scientific data. And yes, I realize that the methodology that was used to capture this data is not always the best. In some cases, it's just downright like bad. But there are indications. I think you would be hard pressed to say that there aren't indications. That there are issues in the way that we work with software, in the way that we output code and deal with bugs and deal with design issues. And a lot of the statements made as part of the conclusions in these studies hit very close to home with what all of us seem to experience in the real world working at your typical company, where you look back and you wonder, how on earth did we get here? Maybe you had really solid conversations at some point in the past where you're like, look, we know that we're cutting corners. We know this is probably not the best thing we can be doing right now, but we're in a rush. We don't have the time. We got to get this out the door. The prototype is good enough. We're going to come back. We're going to put the money and time into it, and we're going to fix these things. And we don't. And it has this huge impact. We can see how these things happen now. There's at least some data that indicates how these things happen and why. And it balloons into, all of a sudden, we're spending probably billions, if not trillions of dollars on cybersecurity and, other issues that come from, like, the issues that are created because of this. So I don't know. I just feel like this is the beginning of actually putting together a data-driven approach to understanding what might be happening. In this stream, it was focused on software. On the last stream, it was web. What might actually be happening and what actually we're doing wrong. But there's more. I am not showing anybody the list of studies and articles and data that I have. It's huge. It's going to take a while to get through, but I'm going to get through it all. So this is not the end. This is not all that I have. I'm just trying to structure the stream so that there's kind of like a flow. One thing leads to the other, leads to the other. Okay. Hang on. Let me catch up on chat in a second. One sec. Okay, I'm gonna catch up on chat. There's also the whole people who like Rust have certain personality type and maybe some patience for the borrow checker. So language correlation has a problem. You're going to run into some major Bayesian analysis problems. It's really easy to shoot yourself in the foot. If it's really easy, you're going to shoot yourself in the foot, your friend's foot, your mom's foot. Yeah. Sheikbot2K. I'm sorry, man. I didn't see your message. Here, let me post the study. And Sheik, this will be on my Twitch and my YouTube going back. I'm going to keep this up for free for a while. And I'm going to be posting a condensed version of this stream and this data plus other data on my Enlightened programming website. And that way you can watch it for free. But then down the road, as I condense these, I'm going to put them in... I'll have the video format, the condensed video up top, and then the written version as well, along with extra stuff that I don't include on the stream. So if you want to get extra things and whatever, you can go on my Enlightened Programming, and I think on the homepage you can sign up to get notified when I put new stuff up. I think there's you can get notified here. For the stuff that I spend time like this on, since it seems like I'm the only one who's actually at least trying to do this, trying to read the data and trying to make sense of it, even if I get it wrong, I'm going to charge something moving forward for this actual data because it's taken me months. And I'll just charge like $1 or $2 or I don't know, something like that. But the idea being that if I can put this data together well enough, then it means that people who are actually interested in this data can use it to make an actual case. Like they can complete a general argument for changes that they might need to make, in their company or something like that. So there you go, Sheikbot. Wow, that's surprising. Go, I mean, although I don't know, I can see people leaving orphan Go routines around. If you don't know, if you have people who don't know what they're using, then yeah, there are all kinds of ways that it could go wrong. And I think what tends to happen is languages like Go, which are good languages for they're a good developer. It's a good developer experience language. If you need to do something like fast and not have a hard time struggling with things, Go is really good for that. It's really good for that. But that also makes it like an easy one to not understand what you're getting yourself into. How are they able to find so many defects in so many projects at once? If it's so easy and the developers would do it too, I think I missed something. So essentially what they did is they looked at the commits and they would look at the commit message to determine whether the commit message had a statement about like fixing a bug or something like that. You can absolutely, like I could do this too. I could actually create a study of like as many GitHub projects as I could get my hands on. And if I took a really, really, really concerted effort into breaking down from my experience, like actually programming as an actual programmer of insert some degree here, I could at least somewhat determine what the message means, and I could create some data around that. So that's it's along the lines of what they did. Yeah, there are tools too. I think it's really important with these analysis to offer some paths to better practice. Time constraint, but what's the solution? Software engineering is hard. It takes work. Yep. Several issues that come up with talking about the fact that legacy code gets bought over time to be thought about. Yes. Yeah. Legacy code. Yeah. I would like for private repos to volunteer for smelly measurements and just report findings. Dojo, yes. I think channels are hard to understand for some people. Yeah, even for me, I still have problems understanding channels, for sure. Offer some solutions. How do we get better mentoring when who you mentor may be competing for your next job? Okay, let me think on that. I think I have an answer for you, Dojo. The whole point is to look at the data to derive solutions that aren't entirely subjective. Right. It might be biased. So projects that actually fix bugs are reported as the ones that had the most bugs. The ones without fixes are reported as great. At the moment, the main theme seems to be inheritance bad. It definitely seems a key aspect. It does seem like a key aspect, right? And so, okay, so to everyone's points, right? Like, so Ghost Magic and I think Laugh, you're both touching on 2 points that are kind of fall into the same bucket, which is just because I'm presenting data here doesn't mean that the data leads to a conclusive interpretation. Right? Hey, Hikaro, how are you doing, man? Good to see you. So just because there's data that's like, let's just assume for a moment that the data clearly showed that OO or inherited paradigms create more bugs than anything else on the planet. Let's just say. That doesn't mean that OO is bad. Because all it's doing is saying people that use OO tend to produce more bugs. Could it be that people that use OO and are forced into a particular paradigm that is more conducive, to bug generation than, I don't know, like some other thing or some other language? So you can't, this is the problem. You can always look at something in a vacuum and say that doesn't sound right. You can always look at something in a vacuum and say that doesn't sound right. I want to be clear that I'm not taking this data and presenting it as in a vacuum, gotcha. OO leads to more bugs. OO sucks. It's a more generalized, it's a more holistic argument. And the argument so far as to whether the industry is in good shape or not always reduces down to, yeah, but developer experience. Yeah, but insert subjective opinions here. Yeah, but me, lowest common denominator. What, you want us to go back to assembly? Blah, 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 blah. What I'm trying to do is add the data to it that creates that more generalistic, holistic approach where it's like, well, it's not just subjective anymore. And even though you can pick apart the subjective, and even though you can pick apart the objective, especially in vacuums, there's enough as a whole to be able to say that we are in bad shape. That's the point. That's what I'm trying to do with this. I am trying to put the effort in that nobody else seems to want to, or seems not want to, but nobody else has as of yet, to actually look at this mind-numbing junk data and try and piece together something that's just a little bit more tangible. So to go back to like what you guys are talking about, in terms of whether the data means something absolutely or not, no, it does not. It does not mean that OO and inheritance is bad just because we looked at a study that said, well, OO, it creates more bugs. The point that I'm trying to prove here is that look at the whole picture. Do you intuitively feel like we're maximizing everything we can possibly maximize with our software and web? Like, come on, tell me, just intuitively, are any of you who are watching this either now or down the road actually happy with the state of software and web? I know some of you are, but I also know a significant portion of you are not. But now try and put that into objective words. You can't. That's what I'm trying to do, is I'm trying to show that there is something that's objective that you can ground that intuitive argument to. Okay, back to chat. Yeah, I read it already. Hikaro, the video will be on my YouTube and Twitch. You can look at the previous stream. I did a bunch of papers and studies on the web side of things and how web is getting worse. This stream was dedicated to software. And then I've got a few more streams planned where I just like go through all this mind-numbing data. Yeah, so I've already gone through it. Also, number of fixed bugs means that the bugs aren't caught by a compiler. True, Dojo, but you do also have to include that there are some bugs that are not compiled bugs because there is no compiler, but they would still be considered bugs. Vancouver, it's been a while. Have you been doing a bunch of late streams on Deep Software? That's pretty awesome. Yeah, so I think I just answered it for Hikaro. The last 2 streams, I've been doing these deep dive, like it's data. I want to be working on the game. I want to be working on Zig and WebAssembly. You know, it's more fun. I'm not working on anything fun, but I care that this industry, I started when I was like basically a kid. This industry has paid for me. It's given me an opportunity to make a name for myself, albeit a small corner of the world, but I'm able to pay for my family. I've come up from living on the streets, living on park benches and in my car and stuff, like literally, to having like a nice little home, and I get to take care of my daughter and my wife, and I get to work on stuff I'm passionate about every day. I hate what's happening to the industry right now. It pisses me off because it ruins it for all of you, and it ruins it for me. And I want better. I just feel like we're in the opposite of whatever the golden age is of software and web. And I'm young enough to remember the days of like Super Nintendo and things like that, where hardware was really restrictive, and the code that you saw being generated in those days was like innovative, creative, clever code because it was necessary to do that. And we have so much more now, and we just squander it. And I hate it. I hate it all. So I want to the first thing I got to do is prove, right? So then, so Dojo, I see that like, yeah, it's easy to see you genuinely want things to get better. I do. Omni, I'll hit you up in a second here. There are myriad things you can demonstrate via perf metrics and tools like Compiler Explorer, but your goal goes far beyond that. Yeah, it's not just the data itself. So again, just to be clear, I want to make a more holistic case, right? The data to back up some of the intuitive, to back up some of the subjective, to back up some of the objective, to back up some of the, more holistic, so that it's not just one or the other. It's like, look, there's some argument here to be made that you can kind of say is more than just, I feel this way. Nah, dude, I love this stuff. I can get really carried away with writing tests. So I find the topic of actual software engineering really fascinating. Yeah, and I think there's at least a consideration. Like today, on today's stream, we went over whether test cases actually help solve the problem of reducing bugs. And the answer is that maybe they do, but what they don't do is tell you bugs that already exist. You can still have bugs that tests do not catch. So when you rely too much on test-driven development, you can have a false positive, or you can have a positive that doesn't actually tell you anything. And you can also have an issue where a test passes even though you've generated a bunch of new bugs. But because your test passes, it gives you that false sense of security. So this is, again, it's a holistic thing, right? It doesn't mean that tests are bad and you should never write them. It means that you have to have enough wherewithal to look at what you're doing and go, am I really getting the full picture? And this is the problem I see with programming in general, the web being the worst offender, where people go, here's this library or framework that it tells me it's going to solve everything under the sun for me, and all I have to do is know this framework. And you just go, great, pat yourself on the back and everything is great, but you're missing a whole bunch of the picture. And that's what I think this kind of data is showing. And that's part of the message that I'm trying to get across. Nobody's looking at the whole picture. Everybody's looking at their little vacuums and going, everything's fine. What are you talking about, Spiro? Things have never been better. On the bright side, though, if you have good discipline, you're better equipped to test against those new bugs. Yes, but how many people have good discipline? And I think the data that I have gathered up to this point bears out. If you just look at cybersecurity issues alone, where vulnerabilities are on the rise dramatically in the last 5 years, we are just getting shittier and shittier. We are not getting more disciplined. We're getting less disciplined. And hackers are taking advantage of that to the tunes of billions, if not trillions of dollars, to the tune of your privacy and my privacy, and to the tune of entire systems that people depend upon for their livelihoods going down for anywhere from minutes to days. Okay, Omni, I know you had some points you wanted to bring out. Hit me. What are the points? Four points. One, do not make this about people with degrees and people without degrees. This is about spending money to get things right or using open source methodologies. I agree. Yeah, I agree. Hopefully I haven't said that very much. Hopefully I haven't I don't think I've presented anything that clearly like says degrees are bad exactly. I don't think you necessarily need a degree, but I don't think this data means anything either way necessarily. Do you think that senior technical people at large companies like Oracle, Facebook, Google, Microsoft, etc., do not know about this? When I say senior technical, I do not mean the CEO. I think a lot more people do know about it at a technical level, and they don't have to be senior to know about it. But I think what's hard is making an objective case for it, and what's also hard is convincing executives who sign the paychecks that the paychecks should go towards fixing these problems, because the executives, what they initially see and hear is, we're going to spend a bunch of time refactoring stuff in order to get to the same place we are today. That's kind of what they're hearing. So what I'm hoping to do is empower people who actually do know and understand, and I think a lot do, from a technical perspective, empower them with data to first represent the fact that there is a problem, and second, represent a solution that's a win-win for everyone involved. 3, why does the US government have a different standard for computer programs than the rest of the US? Is it because the military knows about what we're talking about and they will not accept what the big companies are? There's only, okay, this is, I can't tell you what, I can't tell you how I know this. The only time that the military works at the level that everybody else should be working at is when they are having when they're in the middle of either, hang on, I just want to get the wording right. I got to be careful what I say. It's centered around war. So imagine this. Today, I say something like, okay, let's just take something that I say all the time. You shouldn't use React. React is stupid. Don't use it. Let's just go let's just lean into it and just say there's never a case where you should use React. It's the stupidest thing in the world, right? In reality, that's not how I really feel, but let's just say I said that. Then somebody comes along and says, yeah, but React makes my development life easy. When I need to create a reactive, like a web page that has like reactivity, so when people click on stuff and stuff moves around, I have such an easy time doing that. Don't tell me, Spiro, to write it in vanilla JavaScript. You could see why that might be true and why the developer experience might matter. And a company might also value that because it means less time spent on reinventing the wheel and all of that. And yeah, okay, great. All right. And then the consequence of that is that maybe React is a little bit less performant than a plain vanilla JavaScript, a duplicate of the same set of features or the same website. And that's all fine and dandy. And now imagine you're the military, and tomorrow a government nation decides they're going to start a war with you. And all of a sudden, your ability to outperform them is of paramount distinction. And the guy who's going to come to you from Big Corp and say, I want to use React because of my developer experience, versus another nation like, say, China, who isn't going to give two shits about your developer experience. What they're going to care about is whether or not they're going to beat you in a war context. And performance, as in code to completion, is going to matter way more than whether you felt good writing it or not. And that is usually the thing that pushes military components into writing code that we dream of having. However, having said that, I do know that there are some military, I guess you could say like compartments, where they don't have those same problems. They don't have those same concerns. And they suffer as much or near as much as corporate entities that make the same mistakes. I help people retire. Try going to ssa.gov to figure out your social security benefits. I help people with taxes. Try going to irs.gov, US government standards. Right. Oh, you have more than 4 points? I thought you said you had 4 points. Well, there's the fourth one. Twitch ads are coming. Freaker3, thank you for the follow. I appreciate it. As systems get older and larger, they get more complex. This is not referring to simple programs that can be written in less than 1 to 5 person years of effort. Think the Oracle database, React itself, or Windows and other operating systems. Hang on, I want to give this a good thought. Added to your last comment, the capitalistic way to fix this is to start a new company to do it better than the existing big company. Yeah, ads, I know. Because we have AI, yeah. Ads, folks, sorry, I gotta wait for the ads to finish. I think I have an answer to number 5. And I also think I have an answer to number 4. But I think Omni's stuck in ad land. So I gotta wait. I gotta wait for the ads to be over. Sorry, folks. I guess after this, I'll end the stream. I'll go back to stuff I gotta do. But yeah. Okay. So just while ads are playing, I think there's a couple minutes on there. Just to reiterate that I'm going to put all this information up on enlightenedprogramming.com. I already have a couple of articles. I think I've got 2 here. Yeah. That just kind of give like an initial intro into the argument. And I'm going to take these streams, I'm going to condense them, and I'm going to put them up here as well. And I'll start putting these things together. And if you want to get notified, like when I put the stuff up, you can just join up and I'll send out an email. I think ads are still playing. Sorry, folks. I know this is Not only do I have a boring stream full of scientific studies, but now I have to wait for stupid ads. How boring is this guy, huh? Listen, I promise. Usually I'm an Omega GigaChad developer. Usually. And I develop cool things that are fun. But in this case, you're back. All right. So ads are probably done. Okay. So so you and Dojo brought up, so Dojo asked a question, which is, well, he kind of like encouraged me to do something, present solutions. In Omni for number 5, you're presenting one of the solutions. I'll tell you right now that I am working behind the scenes on exactly a solution like that. Here's the problem. Whenever I come up with like an idea, let's say an idea for a business, this has happened to me before, or whenever I say like, hey, maybe we should be doing this or that as programmers or in the industry. And it might not be starting a company. It might be like a practice or something. I am always met with, why would I do this? Why would you do this? What problem are you trying to solve? And then the problem is, but the problem is like that things are bad and I want to make them better. And then it just goes back to exactly what I'm talking about. What do you mean things are bad? Things are fine. Developer experience has never been better. Look at the things that we can do with our frameworks and libraries and all of that. In order for those solutions to have more meaning, you have to be able to present the problem. And so far, I do not feel like I'm presenting the problem very well. Maybe a little bit well, but not very well. So to begin with, there's a presupposition that people have to accept, which is Spiro wants to recommend a better, better hiring practices because I have ideas on hiring practices that I think we should change. But it doesn't mean anything if nobody thinks there's a problem in the first place. So I have to get to the point where I've done enough work that I can at least feel like I've made a reasonably sound argument for the problem. That way, when I come out and say, here's a potential solution, whether it's create a company that solves a problem or suggest like on stream or like, I don't know, whatever, hey, developers, we should be doing this or that. If somebody asks, yeah, but why, I can at least make a more holistic argument as to why. For number 4, while I think you're right that things get more complex the more time passes, there's still an issue with A, some of these things started off wrong, and B, they don't account for all issues. So there are still new things that have come out in the last 5 to 10 years that have not been around as long as 10 plus years, like 20 or 30 even, and cannot fall under the same category of the longer they've been around, the more complex they get. So it's a part of it, but I don't think it's all of it. Yeah, but they have licensing. Yeah. It's a trade instead of a profession. Right. I mean, I don't know. Are you I don't think you have to be licensed to be a programmer necessarily, but gee, I might consider the idea. I cannot say I'm against or for it right now. I'd have to think about it. Right now, people in the trades have unions that protect their jobs. Software engineers do not. I have a fundamental issue with unions to begin with. That's why we're never going to be real engineers. Yeah. The IEEE wants to license engineers. The ACM does not. I don't know if a license is a bad thing or a good thing. I'd have to think about that. It might be fine. It might be fine. I'm not sure. I'm going to give that some thought. That could be a possible. Yeah, I don't know. Engineer is a protected term in lots of places, including places in Canada. That okay, that's true, man. People who design bridges have a license, right? So, like, I guess would you consider programming the kind of like in the same vein as building a bridge? And I'm not. That's not a gotcha question. I could see an argument for and against that. It's not a gotcha. Maybe licenses for particular domains. Maybe, yeah. It should be. We applied to be software engineers and became devs. Right. Right. Yeah. Omni, I see what you're putting down there, man. I see what you're putting down. Yeah, it's true. It's true. You're a licensed electrical engineer. Technically I am too. Although maybe it's expired now. Not web dev so much, but some code can kill people and right. No, yeah, Dojo, exactly. Exactly. Now, or imagine that like you brought out the points of like the IRS or something, right? What kind of an impact? How do you know that doesn't have a downstream effect of like ending someone's life because they couldn't properly get the information they needed from the IRS website? You know, I get it. It's a bit of a flimsy connection, but like you don't. It's a really hard one to like definitively say yes or no to, right? For specific domains, great idea. Obviously, writing a video game is a lot less critical than like MCAs. I could see that. Yeah. That's why the military has two sets of rules. If you're designing software for a ballistic missile, you're not using React with an intern signing off. Okay, so Omni, I think I think then you would agree with what I said earlier, which is when it comes to war, what matters to military in terms of code is not the same thing as what matters to companies in terms of code. You can make a case that like, well, companies aren't firing missiles. Okay. But this is what I'm trying to prove, right? To Omni's, right, just like the website has to work and attract customers, right? Okay, so Omni, maybe you're actually maybe you're making like a more detailed case of the same case I'm making, which is if that's the standards the military lives by, why should it not be the standards that other companies live by? Because there is something to be said about the outcome of your code and the performance of that, right? And if it matters to the military, then there are definitely instances where it must matter to a corporate entity. Maybe not for like video games or something. However, I would argue that even things that are tangentially related to the ecosystem of the industry, like video games, have a downstream effect. If you just didn't care about what you did in video games, but video games brought in a lot of money, brought in a lot of developers, and were used as like the standards by which others plucked from, and you're doing crappy video game design, then by the entailment of that would be that everything else is therefore crappy too, because they take the learnings from the video game industry, right? So I think it would actually be hard to argue that even tangential things like video games or like smaller websites or whatever should not aspire to have the same kind of quality of output that like a military system tends to have. And in a holistic view, think about it this way too. Imagine if everybody essentially more or less took the methodology of we're going to try and pretend like we're in wartime, and all the other companies that are competitors are essentially like at war with us. What would you do to win the war? Lives are at stake. Well, you're not going to go and pick up some complicated set of like 600,000 dependencies that you don't know what they do and piece together something so you can get it quickly out the door. No, you're going to spend every single ounce of strength you have getting that code quality to be just freaking right and super as performant as you can be with as few bugs as possible. And that's going to mean you're going to do whatever the hell it takes to do that. If everybody had that kind of thinking, or a lot more people did, imagine how the industry would change, the kind of quality of software that we would produce, and what the daily impact of that would be in just general life in general. And I think maybe Omni is making a more detailed case for that. Video games are very advanced, much more than your average business app or website. Right. But then people look to video games as like here's an example of something I should do, right? And if video games are built crap, then yeah. Although software system to control AOA in an airplane because you didn't want to redesign a new plane to stay competitive is probably a sign of other things related to exactly what we're talking about. Yeah, Vancouver, yeah. Dojo says, I've seen the direct effect of poor design of SSA.gov and IRS.gov. Confusion, fear, depression. The KP.org Kaiser website is a mess. No, sir, you can't have your antidepressant. Don't talk to me about Kaiser. I've worked with Kaiser Permanente. That is like a mess upon mess upon mess upon mess, layered down like 10 layers down. And that's only one aspect of the Kaiser Permanente arm that I worked at. I know they have several arms. How many doctors kill people in front of someone and get to keep doing it? If you cut off the wrong leg, you lose your license. My wife's neurosurgeon charged $3,500 an hour back in 1992. Yeah, Omni. Yeah. So that's interesting, Omni. I think you're making like a far more you have a lot more detail. Like you said, you have more experience. So the detail that you're able to get into to kind of like essentially riff off the argument that I'm trying to make is good. I appreciate it. I might steal one or two of these things from you. Well, if you went to college for 15 years, I'm just going to be honest, straight talk, then you're one of the few people who are college educated that I would actually consider intelligent. There are a lot of people who went to college or university and I consider intelligent. Don't get me wrong. It's not like they are few in number. I'm only talking about like anecdotally the number of people that I do know went to college who are smart versus not. That's all I'm saying. Then I worked for many companies. Yeah. I remember you told me your history, Omni, and like that's not a small thing. It's not a small thing, man. I know. Reminder that I was in a master's course with a guy that didn't know what an array was. Yeah. And I see more of that than I see people coming out of university or college who are actually intelligent. Like really, like the level of intelligence you would expect from people who took the courses they did and have the degrees they do. So I would put like Omni would be under that bucket. But to be fair too, I also see people who never went to college or university and are also just as intelligent as some people who have. I don't think it's the end all be all. It can help though. It can help. Don't get me wrong. It can help. Okay, folks. Okay. That was good. That was a good stream. I appreciate it. I appreciate all of you being here and watching. And then in the future, for everybody who's watching, maybe on the Enlightened Programming website, or maybe reviewing the stream on Twitch and YouTube, I appreciate everyone watching. I do have a Discord channel, and if anybody cares to join, you can reach out to me there. My DMs are open, same as on X. I think I have my email somewhere on one of my websites. You can reach out to me if you want to reach out to me for something. But I'm going to end the stream. I'm going to consider it the end of the stream. Many of the best programmers have physics degree. That says something. I actually do agree with that, Omni. Yeah, I agree with that a lot. At least anecdotally, I can say that. You have a physics degree here, Lowly Finance. Collaboration. You want to do a collaboration, Dojo? Hit me on Discord, Dojo. Yeah. Omni is on Discord. I'm on Discord. Hit me on Discord, Dojo, and we can if you want to do a collab of some kind, let's do it, man. No, thank you, Laugh. Thank you. So thanks, Raiders. You guys are awesome. All the new viewers and subscribers and stuff today, I really appreciate it. I'm probably not going to be back until next week. I hope I can do another stream tomorrow. I don't know. I can't make promises. I'm going to try and be back tomorrow, but if not, then it's going to be next week. I'm going to plan out the next set of articles and studies that we're going to look at. I'm going to try and keep it thematic like I did today. And I'm really, really sorry to everyone who comes and like wants to watch someone code exciting stuff and have fun. I just care about this a lot. It means a lot to me. And I don't actually enjoy doing this. The research was kind of fun, but it is boring. But I'm hoping it helps somebody. All right, let me find someone to raid. Let me go over here, and then you know what? I think Travis is on. And if Travis is on, we're raiding Travis. He's on. We're raiding Travis, boys. Okay, so here's the deal with Travis. Hang on, what's chat saying? Not everything in life is exciting. Studying hard in school can be boring. It's true, Omni. You're right, man. Yeah, that's a good point. I've not actually managed to catch you at coding, but the discussion is interesting. Sorry, Car. Listen, I promise, if you go back on previous streams on my YouTube and I think on Twitch too, I have months worth of content where I'm literally coding a WebAssembly game in Zig. And it's fun, okay? So you can go back and you can watch some of that if you're looking for something to listen to in the background, okay? But I just care a lot. Like I just want to try and get to the bottom of this, or at least make an attempt. Even if at the end of this, all the people call me out on all these studies and are like, "You're stupid, Spiro. It doesn't actually say what you think it does." At least I tried, and at least we'll be better prepared. Like we're better suited with all this information in hand to provide like a more data-driven argument, either pro or against whether the industry is in shambles or not. That's better than not having this data at all or not even reviewing it. So I'm sorry, Car. I'm sorry. You're here for the hot takes and the rants. I'll try and do more. Here, I'll start the raid over to Travis. Listen, folks, please make sure that you say hi to Travis. I can't say enough good things about Travis. If you want to watch somebody who takes kind of like the principle of what I'm trying to say here to an insane degree, Travis is one of them. Spherophoria is another. So Travis is working on his own video game 3D game engine. He's using C and Vulkan, and it's just straight up vanilla. He's not using libraries. He's not using there's no cheating. Like he's raw dogging the whole thing. It is humbling to watch this guy code. Give him lots of love. Make sure you send some give him some subs or follows or whatever. He deserves it, man. And while you're there, you're gonna learn a lot from him. I promise you. And it's been a long time since I've been able to raid Travis. He's a solid friend of mine. So, okay, that's it. Good night, everyone. Have a good night. Have a good day wherever you are, whatever you're doing. I really appreciate all of you. You guys are awesome. Thank you for sticking it out with me. Genuine appreciation. Thank you. I will see you as soon as I possibly can see you again. All right? Peace out, guys.